over just few minutes. Hey, jumping like anything. Don't know when this will be over. 1 minute. Yes. Now okay. No more further corrections. I'm going to check it. Orientation. Class 45 continue. Class 45, class 46. Slightly move. Upper and lower side, some space is left out. It is better because I want the full board because sketches are coming. So upper side, lower side, what those things visible, don't see it. You see only the screen. I told already. Show off is not required. Correctly set so that there is no offset there. That's all for, not for education. Just a minute, just confirm the recording there. Is voice clear? Audio and video both are okay? Audio, video both are okay? Okay, I'll start. See, this live stream will go up to 9:30 today, full class. Make a note, in case any problem comes, either due to network, sometimes suddenly network problem, or any reason, if live stream is stopped, immediately do one thing. For the ETAB and SAFE batch, those who are in the group, I have sent a link. 2 more links I have sent. Got it? I have sent 2 more links. You got it? 2 more links are sent. You got it? those who are in the ETAB and SAFE batch. I sent 2 more links just now. You got it? Yes. Use first one. If by chance this live stream is stopped, within 5 minutes I will start live streaming. Use the link design of staircase continued. Remember, continued. By chance if there is any problem further later, then use the link ETABS design of staircase continued further. See, continued and continued further. Use that one. That is what those who are in the group. Others, those who are, that is general public. Then what to do is, if live stream stops, go to my channel. That's all. It is actually unlisted. Right now those 2 are unlisted. Because why? It is not made public. If I make public, all will get notification. Because timing is some 6 o'clock, 7 o'clock I wrote. So it is not made public. I will make it public and start. Immediately you can see in the channel. In the channel you can see. Or if you are subscribed, notification will come for you. He is starting design of staircase continued. Once again it will come. Design of staircase continued further. So others what to do is, in case live stream stopped, in the channel see the streaming. I will make it public. The moment I make it public, it is it will go for everywhere. Okay. Now see, one important note for others, not for this group. I am considering design of staircase here. Today I am going to finish it. In case little portion is pending, I don't want one more class. I will explain all the principle today regarding design part, and also load. See, most important is load transfer. From staircase, load transfer to supporting beams. I will explain everything. In case time shortage is there, no problem. Explanation I will give today. I will make a recorded class and upload in the YouTube. I will put a recorded class. I will write there what extra information or extension of the class, recorded class. Clear? In case it is not over today, then I will go for recorded one. But no more live, because coming Saturday we got that beam detailing pending. That up to where bars has to be extended, top bar, where bottom bar can be curtailed, those things. And immediately we are going to save. We are going to save there. I do not want the staircase there. Today only staircase. Okay, start. Now, even for those who are in the group and also for public, remember, when I design the staircase now, so many things are there which is RCC part. That I am not going to tell again and again. It is all told for you in the earlier class, design of slabs and other things. But briefly I will explain, so that those who have not attended that one, not in the group, but if you are not in the group, if you study staircase design, by that time you should know slab design. See, first make a note. See. One important note is there. Keep on. See, this note correctly remember. I will not repeat once again. See, just imagine, consider a slab. Consider a slab. Now, anybody can tell supported by beams in one direction, sufficient. Support beams in one direction. Can you tell me what I am telling now? Anybody can tell what I am covering, so that during staircase I won't talk. What I am covering, anybody can tell? I told consider a beam, consider a slab supported by beams. Any idea? Or tell no idea? If no idea means tell no idea. What I am telling? I am not telling slab design. Tell me what I am telling. Not slab design, the most important part for software. What is that one? Most important part for software. This much difficulty to understand. Tell no idea. At least if there is no idea, tell no idea first, so that I can continue. Not beam. No idea. Okay. See. Imagine slab is spanning like this. See. Slab supported here. See. Imagine there is one beam here running this way. One more beam running this way. Remember now? This I am telling for those people who are in the group for ETABS modeling. Remember. Others, it is extra information. ETABS modeling. See. This is the slab. Cut. Maybe, okay, now. This is the slab here. See, the slab is now spanning like this. This slab is spanning like this. This is a beam here. Okay. See, imagine center to center is some span L. Now, see, now tell me, when you design the slab, what is the most important? When for slabs, most important term, what? Fast. Most important term for slab. See, in case of beams, cross section is B by D. For beams, the cross section is B by D over. B is the width, D is the depth. If I take the cross section here, for slab also, cross section is B by D. Cross section is slab also, cross section is B by D only. But remember, D means what? Tell me. This for slabs, this D means what? Fast. Do not waste time. For slab, the D means deflection. You are teaching me too much. For slabs, D means what? Fast answer. D is 1 meter. Where all you get these ideas from? For slab, beam width by depth. For slab, D stands for thickness, slab thickness. Slab thickness or thickness, you write, or depth of slab. Okay. What is B? Tell me. See, if the beam is going this way, this is depth. See, if you take cross section here, span is this way. This is the span. This is the depth for beam. This is the width. For slab, width is spread. Therefore, what you do is, see, the width is not specified. See, suppose there is beam, room, slab, 4 meter by 5 meter. See, imagine this way 4 meter, this way 5 meter. If I design the slab along 5 meter, width will be 4 meter. If I design the slab along this 4 meter, width will be 5 meter. But that way people don't take. For understanding what you do, we always consider what? For slabs. Remember, for slabs, we always consider what? We consider 1 meter strip. 1 meter strip. How it is? See, if the slab is spanning this way, remember, strip will always go along the span, this way. This is the width strip of the slab, width. This is 1 meter. Now if I take cross section, what I can see? If I take cross section now, you can see slab like this. This is width of slab B, this is D. D is the slab thickness. D is slab thickness. This B becomes 1 meter. Correct or not? This B becomes 1 meter. Clear now? See, here if I take cross section, or see here, when you see lengthwise bending, B comes here. This is your 1 meter. See, this is your B, 1 meter. Now, in case of beams, see, suppose there is a beam. Any span, you put load in usually kilonewton per meter. But for slab, when you take per meter length, if you take 1 meter length, width also is 1 meter. Therefore, for slab, the kilonewton per meter, this is for beam, will be what? Will be what? Kilonewton per meter will be kilonewton per. This all I told earlier. kilonewton per what? It is kilonewton per meter square. Remember, per meter square. Now, even though it is, see, sometimes people have difficulty. When you do bending moment for beam, WL square by 8, for example, see, W, 20 kilonewton per meter. Imagine span is 5 meter. You write 20 into 5 square by 8. See, 20 in kilonewton per meter. 5 square is meter square. Kilonewton per meter into meter square, it will come kilonewton meter. Correct. But for slab, if you take the load same way, if you take load as 20 kilonewton per meter square, when you take bending moment, 20 into 5 square divided by 8. 20 is in kilonewton per meter square. 5 square is meter square. Tell what happens? Kilonewton per meter square into meter square, it will not become kilonewton meter, it will become what? It will not become kilonewton meter, it will become what? If it is beam, see, kilonewton per meter into meter square, kilonewton meter. Slab, kilonewton per meter square into meter square will give kilonewton. Clear? Clear or not? It will give kilonewton. Fast, clear or not? No, wrong. This is a wrong concept. It is not kilo. How the bending moment can be in kilonewton? This also will come in kilonewton meter only, because this 20 kilonewton per meter square is kilonewton per 1 meter length and 1 meter width. Don't see width for bending moment. Lengthwise bending moment. When you take lengthwise 1 meter, it is 20 kilonewton only, or kilonewton meter per meter strip. So, therefore, in case of slab, in case of slabs, even though we write loading as kilonewton per meter square, it is actually what? It is actually what? Kilonewton what? Even though you write kilonewton per meter square, it is actually kilonewton per what? It is actually kilonewton per. Other width is not considered. Even though we write kilonewton per meter square, it is actually kilonewton per. Fast. It is actually kilonewton per. Even though we write kilonewton per meter square, it is actually kilonewton per. You are delaying lot. One word required, not meter square. It is what? It is kilonewton per meter only. But other meter is this way meter. So you write kn per meter square, but when you imagine along the span kilonewton per meter. Okay, now second one. In case of second, see, this is one concept. I will not repeat once again. Remember, in building project also this will come. I will not tell once again. Remember. Okay, now, second point here. This over. There's a second important point. See, suppose you take a beam supported by column. Load is 20 kilonewton per meter. Span is, say how much? Same, 5 meter. Tell me what is the reaction? 20, imagine symmetrical. 20 into 5 divided by 2 equal to 50 kilonewton. This also 50 kilonewton. Why? Kilonewton per meter into meter by 2 kilonewton. This is upward reaction on the beam from the column is 50 kN. Therefore, later when you consider the column, there is a downward load of what? From the column to the beam if there is a upward reaction of 50 kilonewton, then from the beam to the column, a load of 50 kilonewton is transferred down. This will give compression to the column. Clear? This is the load transferred from beam to column. Okay. So therefore, no problem. Why? It is axial load this way. Kilonewton. Now, important here. Suppose I find bending moment here. See, imagine L is 5 meter. Imagine W equal to 20 kilonewton per meter square. Okay. Now, suppose I consider this slab. This slab. This way. This way. This is supported by beams. Supported by beams. See, UDL is what? UDL is 20 kilonewton per meter square and span is 5 meter. Tell the reaction here also. Here also, react for the slab reaction. Reaction for the slab, how much? 20 into 5 divided by 2. This also 20 into 5 by 2. How much? 50. 50. Tell the unit. 50 what? Unit. Nodi. 20 kilonewton per meter square. 20 kilonewton per meter square. Into 5 is meter. So answer. 50 is kilonewton per what? It is 50 kilonewton per what? It is 50 kilonewton per meter. Correct. Now what you do is for SFBM calculation 20 kN per meter square, you take 20 kN per meter. 50 kilonewton per meter, you take 50 kilonewton, because that per meter is per unit width. Now, when you consider the beam, now see, when you consider this beam, supporting beam, see what happens, tell me, I will put 3D here. If one beam, suppose I this beam, I will put 3D here. Inclined, I show this way. See, the slab is resting for staircase, or the slab is resting for 1 meter length. For this 1 meter length of the beam, it is transferring a load of how much? 50 kilonewton. Therefore, remember, if the reaction is 50 kilonewton for 1 meter strip, tell me, from the slab, when the load is transferred to beam, it becomes what? From the beam, when you transfer load to column, it will become point load. Same way, when you transfer load from slab to the beam, it becomes what? When you transfer load from slab to the beam, it becomes what? It becomes not point load. Along the beam, load is spread for what length? UDL. So this 50 kilonewton is on the beam spread for 1 meter length. Therefore, it is UDL. Therefore, now make the last note. It's all over. Last note. First note, I will tell without writing on the board. Because why? You write. First one, I will not write on the board. You write. If you consider a beam supported by a column, load on the beam, UDL, will be kilonewton per meter. Reaction will come in kilonewton. What reaction comes upward, reverse it, downward will become point load for the column or axial load. Over. But when a slab is supported by a beam, then slab you consider always, when slab is, now second point I am telling, first point you write, slab is supported by beam, any beam, by a beam, then slab load we consider in kilonewton per meter square. That is for 1 meter strip. It is because you take 1 meter strip, okay, kN per meter square. But actually, you imagine it as what? For structural calculation, imagine kilonewton per meter. Then reaction will come in kilonewton per meter. For structural calculation, you take kilonewton, no problem. But remember, this kilonewton per meter reaction for the slab, whatever comes is what? This reaction on the slab from the beam in kilonewton per meter strip is, when you reverse it, will become UDL on beam. Will become UDL on beam. Clear now? Concept clear? Even though, see, if you take load in kilonewton per meter square, reaction will come kilonewton per meter. Kilonewton per meter square, you structurally you calculate, consider kilonewton per meter. Kilonewton per meter is kilonewton. That per meter is width, this way meter, not required for us. When you transfer load from slab to beam, whatever reaction is there for the slab, that is the not point load, it is UDL for the beam. Clear? Clear or not? I am not repeating again and again now. This is clear? It is UDL for the beam. Over. Okay. Now, go to some other points. See, now some other point, I will just dictate here. I won't write because all of you are knowing it. Those who are in the ETAB and SAFE batch and also those who are in the RCC batch, this all you know it. Others should know it. Otherwise, briefly. For a slab, diameter of bar diameter should not be taken more than 1/8 of slab thickness. One concept. And minimum clear cover is 20 mm for what? For mild exposure and 30 mm for moderate. We will always take moderate. We will not take mild, moderate. So 30 will take. Then next point, slab thickness to be decided based on deflection control. This all I will tell you, deflection control. Then slab thickness should not be less than 100 millimeter at any cost. And self weight of the slab and also floor finishes will give you dead load for the slab. Plus there will be live load. These are the two loads on the slab. But if it is a floor slab, you take one extra called partition. Staircase are not required. Okay. Then find bending moment. Effective spare I will tell you. Bending moment. Let mu be factored BM. Factored maximum BM. Then beams can be either singly aimed post or doubly aimed post. In case of beams, if mu is less than or equal to mu limit, it is singly aimed post. If mu exceeds mu limit, it will be doubly aimed post. Of course, some limit is there. Remember, vehicle. You cannot have 1 lakh rupee with you and go for a loan of some 29 lakh rupees and purchase 30 lakh worth. If it's a hand loan, hand loan from fund. If you want to buy a car of say some 10 lakhs, at least you have 5 lakhs with you. So if the bending moment exceeds 2 times the limit, it is advisable to redesign the section I told in beams. And slabs are not doubly aimed post. Slabs are always singly reinforced. Therefore, for every slab, your mu should not exceed mu limit, or you should always get mu less than or equal to mu limit. Then, how to find area of tension steel? Find AST by the equation mu equal to 0.87 Fy into AST into D into 1 minus AST Fy by BDFCK. On solving, it will give quadratic equation. Take the least value. 2 positive value will come. lesser is the AST required. Next, for slabs, minimum steel in any direction is 0.12% of gross area in case of tar steel. However, remember, if you use mild steel, we are not using. Why waste time? Generally, 0.12%. You should not give steel less than 0.12%. Tell me, if it is mild steel, how much it is? If it is mild steel, how much it is? If it is mild steel, how much it is? Tar steel 0.12%. Mild steel we are not using. Still, if you use mild steel by chance, nobody will use mild steel. How much? If 0.15%. Okay, write that one. Mild means 0.15. Okay. Then next further parameters. I am telling for ETABS batch as a revision and general public as what? Information. Once you get the AST required, you compare with minimum and decide AST to be provided. Then you have to in case of beams, you find number of bars. In case of slabs, you find spacing of bars. Spacing of bar equal to cross-sectional area. I won't tell once again now. Area of 1 bar divided by total area of steel required, area of steel to be provided per meter strip, multiply the width B in meter equal to 1 meter or 1000 millimeter. When you take per meter strip, it is multiplied by 1000. So, area of 1 bar by total area of steel it to be provided into 1000 will give spacing. Okay. Then, as per IS code, for main reinforcement, spacing should not exceed 300 millimeter. Second one, 3 times the effective depth. Among the two, whichever is least. However, for distribution reinforcement, spacing should not exceed 450 millimeter. Second one is 5 times the effective depth. And now, lastly, check for deflection control. Deflection control. How to check it? Find L by D actual. L by D actual. Remember, L by D actual is the danger number. I told you, this is the danger number. This we want as much as less as possible. L by D actual is the danger number. Okay. Find L by D actual. Then, after that one, find L by D in the bracket maximum permissible equal to a constant based on end conditions into modification factor on tension side. The constant based on end condition is 7 for cantilever, 20 for simply supported, 26 for continuous. And modification factor on tension side is given by, I'll write here, I'll remove this one. And remember, modification factor on tension side equal to 1 by, forgot. If I remember, 0.0032 plus 1 by 0.0032 plus, anybody can tell the answer? Plus, what is the next number? Who remember? 0.225, 1 by, tell the number. Who remember those things all? I cannot buy out the formula. 1 by 0.225. No. What is the formula? 1 by first number. I do not remember the number. I have given you those who are in the batch. 1 by, I think it is 0.225, I think first, correct? I think it is 1 by most probably 0.225 plus, who remember this one? Then, tell the formula. Long, okay, 1 minute now. This formula I will write later because I don't remember. See, I am very weak in by hearting. If it is a derived equation, I never forget. If it is a derived one, I can derive always. This is empirical. I will write later. Do one thing. One of you in the group, see the old notes fast in the WhatsApp, in the group, send me the formula. You send the formula. Agreed? You take a photo of the formula and send me. Agreed? Later, at earliest possible, take a photo of the formula and send me. Agreed? Agreed or not? First. Take a photo and send me. I cannot remember. Or I have to search now where the old notes are there. Somewhere it is there. You are not answering. Take a photo of the formula and send me. Agreed? 1 by 0.225 plus 0.0032 times Fs. Yes. 1 by, thank you, correct. 1 by 0.225 plus 0.0032 times Fs plus what? Plus 0.625 into logarithm to the base 10 of Pt. Correct? Correct now? Logarithm to the base 10. Because in mathematics and structure engineering, if you simply write log, it is to the base e, not 10. I think formula is correct. 1 by 0.225 plus 0.0032 Fs plus 0.625 logarithm to the base 10 of Pt. Yes, okay. Now, 1 by 1 term. Here, Fs is stress in steel at service load given by this. I don't require because, tell me why, because this is proved one. I don't require IS code. It is 0.58 times AST required divided by AST provided. 0.58 Fy into AST required by AST provided. Clear now? AST required by AST provided. Clear or not? 0.858 times Fy into AST required by AST provided. Clear? Okay. Now, and Pt is percentage of tension reinforcement. Remember, so many places they write tension reinforcement provided. Technically wrong. I proved it in the RCC class by talking 1 hour. If I meet IS code next time, I will raise a big issue there. It is tension reinforcement required. That's why it is called PT required equal to 100 into AST required divided by BD. Now, one small problem. AST required comes by equation where, see, I told you, mu equal to which equation? Mu equal to 0.87 etc. Equation, you get AST required. AST provided is, see, lastly, AST provided depends on spacing provided. Actual spacing provided. So remember, for that you have to use the formula. See, spacing equal to area of 1 bar by area of steel to be provided into 1000 interchange, you get AST provided equal to, see, your spacing equal to area of 1 bar by AST to be provided into 1000 because 1 meter. So AST provided equal to, see here, equal to what? Equal to 1000 divided by spacing provided. Ulta, see, 1000 divided by spacing provided multiplied by area of 1 bar. Remember, when you want spacing, use this formula. Area of 1 bar by total steel to be provided into 1000. When you want, once you provide the steel, if you want to know what is the actual AST provided, then it is 1000 by spacing into area of 1 bar. And for your information, I will write somewhere here. I will forget later. 0.225. Who knows? 0.0625. 32. I will again forget it. And 0.625. Okay. And for your information, those who are in the ETAB and SAFE batch, you don't have to perform check for deflection manually. Tell what to do. Tell me what to do. You don't have to struggle. All you require is what? Use what? Very thoroughly we covered. To check for deflection, it will take 10 seconds. What do you have to? Tell me. Those who are in the ETAB batch, you can tell. To check for deflection, what to do? Fast. You don't have to do all these things. Directly it will tell you safe or unsafe. Tell what to do. To check for deflection control for slabs. What to do? Fast. You are not answering. What you have done long back in slab marathon. When you want check for deflection, I told you during project also same thing. You got Excel sheet. Use the programming. We got Excel program to check it. Today what I will do is, when the check comes, briefly I will check manually. Simultaneously, one of you check in Excel and tell me answer tallying. Agreed? One of you tell me check by Excel and tell answer tallying. Okay. Now, this is for slab. Now, further information, last information before I start design of staircase. See, I may not be able to cover all the cases today, but I will tell you all the principles so that I will upload the extra classes so you understand. See, now, in case of ordinary slab, see, slab is like this. Self-weight will act like this. Floor finish also will act like this. Live load also will act like this. So, if I take the slab here, see, this way slab, strip up 1 meter, etc. Load is downward, bending comes this way. Yes or no? Therefore, no problem, just similar to beam. Only change is we consider 1 meter strip, load is kilonewton per meter square, reaction is kilonewton per meter. Kilonewton per meter square is kilonewton per meter only. And reaction, kilonewton per meter is kilonewton for 1 meter length. Okay, now, in case of staircase, see, there is 1 meter. I drop the cover. If the cover is not there, this will stop writing. 1 minute. Where is it? Just a minute. I got it. Luckily got it. See, in case of staircase, imagine there is a landing slab here. See, this way. Okay, sufficient. Then, this is the waste slab. It will go like this here, see. This is the staircase. Now, see here. This is the landing slab, horizontal, landing portion, horizontal. This is called going. See, this is the inclined portion. People call this as going. Horizontally called going. See, this length horizontally is called going. Remember, later I will not tell. Here, see, whatever is the inclined portion is there, its horizontal equivalent is called going G. Clear? I will not tell once again later. You require now. It is called going. Later, nobody should ask, sir, what is going means? Clear? CIS code. Where inclination is there, its projected horizontal length is called going. Okay, that is called going. Okay, over. Now, see, here, self weight acts this way. Finishes also acts this way. Live load also acts this way. So, therefore, no problem here. No problem here. Loading is vertically down. This is the span. Correct? This is the span. Tell yes or no. Same thing here also. Same thing here. Fully clear? For landing, it is like ordinary slab. Landing slab is this way. Load, self weight also is vertical. Then, self weight vertical, finishes vertical, everything is vertical, span horizontal. Full clear? Tell me first. Okay. Now, consider the inclined portion. Tell me. For inclined portion, here also, live load is vertical only. Remember, for inclined portion also, live load is vertical only. Don't tell horizontal. Live load is vertical only. Correct? Nobody is going this way. Live load is vertical. And then, weight of steps also is vertical. Is this way. See, weight of steps also same way. Then, what about the waist slab? What about the waist slab? Live load is this way. Weight of steps are this way. What about waist slab? Vertical or inclined? Waist slab. Vertical or inclined? Fast. Only waist slab. Inclined. No. Sorry. Wrong. Weight of waist slab also vertical. How you got the idea? See, if I have a pen here, if I drop, it will come vertically down. If I have an inclined pen here, if I drop, will it go this way? Tell me. Will it go this way? See, I have a pen horizontally placed. I will drop it. Come down vertically. I have an inclined pen here. I will drop it. Will it go this way? It is vertical. But one problem, it is vertical, no doubt. But important is, see, that total load, the self weight, total load depends on what? See, here, total load depends upon horizontal span. Total load depends on horizontal span. Here, live load also. Live load and weight of steps all depends upon horizontal span. But total load of what? Waist slab, self weight of waist slab. Total load depends on what length? Horizontal length or inclined length? Tell me. Total load depends on horizontal length or inclined length. Load is vertical only. But the total load when you calculate, it depends on horizontal length or inclined length. First, horizontal length or inclined length. The total load depends on inclined length. Inclined length depends on inclined length. Remember, even then, load is vertical only. If load is vertical, when you take moment, you are right, load into this distance. So, for bending moment calculation or shear force, we consider horizontal span. But total load depends upon inclined length. So tell me what to do. Therefore, for self weight of waist slab, we have to increase the load or decrease the load. Tell me. We have to increase the load or decrease the load. Self weight of waist slab. We have to increase the load or decrease the load. Tell me. Self weight of waist slab. We have to increase the load or decrease the load. Fast. I won't go to theory portion here. If you remember, those who are in the RCC batch, I proved it mathematically also. We have to increase the load. We have to increase the load intensity. load intensity. Because, see, because reason, you write, load on a larger area is spread on what? When you take, this is the span, see, this load, you take like this. So, load from a larger area is spread on smaller area or larger area. See, if it is this way, load coming for a larger length is spread on larger length or smaller length. Load on a larger length is spread on what? Larger length or smaller length? First, smaller length. When the load on a larger length is replaced by equivalent load in smaller length, total load should remain same. To get the total load, you need increase or, see, suppose for example, see here, if it is along the inclined length, if the load is 10 kN per meter, that is for inclined length of 5 meter. Imagine for same 5 meter, horizontal span is 4 meter. Tell me, what is the UDL here? It is 10 kN per meter for 5 meter is the total load divided by how much? Tell me. 10 by 5 divided by. Total load should remain same. 10 into 5 is the total load, but divided by how much length now? Divide by. 10 into 5 is the total load, divided by. How much? Divide by. To get equivalent in plan, divide by. First. 10 into 5 is the total load. It should be divided by how much now? If you want to spread it for 4 meter length, to get the same total load, divide by intensity. 10 into 5, 50 kilonewton. Earlier, 50 kN spread over 5 meter. Now 50 kN spread on 4 meter will become 12.5 kN per meter. Or I will give formula for you. There is no, see, if it is a RCC class, I will tell normal component, tangential component, etc., etc. Anybody who came to RCC class, remember, I told all those things. Normal component, tangential component, resolution, all. But there I did the BM 3-4 times by taking some normal component and inclined span, etc. Everywhere answer came same. But this class is not for that theory. So remember, what you do is, so remember, self weight of, see, find self weight of waste slab in kilonewton per meter square. Note, this is for what? Area along inclination. Therefore, we have to increase the intensity when we consider horizontal span. That is, we have to find equivalent load in plan. Not plan. Now remember formula. Equivalent load in plan equal to equivalent load in plan equal to for only for what? This is for what? For self weight of waste slab. Not for live load, not for steps weight. Self weight of waste slab equal load in plan equal to what? Tell me. Whatever is what? Self weight calculated for waste slab. That is, I told you here. First find self weight of waste slab. Say W dash. slab, say W dash into square root of, remember formula is into square root of T square plus R square divided by T, where T is the tread and R is the rise. Clear? Multiply. This term is magnification factor. Magnification factor. Therefore, what you have to find the weight of the waste slab by usual formula. How to find it here? Tell me. Very simple. Thickness into density. Thickness into density. No width. It will come in kilonewton per meter square. Whatever you calculate, thickness into density, because width is not there, it will give self weight of waste slab along the inclined plane. Now, whatever you get the answer, change it to get equivalent in plan, just to understand, so that later no trouble. One mini example. Let waste slab thickness equal to 150 millimeter, and also let R equal to 160 millimeter and tread equal to 275 millimeter, random number, rise and tread. Now, see what to do. First, self weight of waste slab. Don't write formula all. Waste slab equal to, formula is thickness of waste slab 0.15 in meter. Width is not there. We want per meter square area multiplied by 25. Tell the answer. It will come in kilonewton per meter square. If somebody asks me, sir, why 25? Don't come to my class. Leave the class. You are not knowing about RCC means why you came to staircase class then? Answer. 0.15 into 25. Width is, for beam you have to write what? Width into depth you have to write. For beam you have to write width into depth in 25. Then you get kilonewton per meter. Now only depth. Answer fast. 3.75. It is 3.75. Now, this load to be magnified. How? Therefore, calculate equivalent of this load in plan equal to whatever answer you got there into square root of T square plus R square divided by T. Remember, here unit is not a problem. Okay, take the answer. 3.75 into root of, since it's in meter square, some will tell sir meter. Okay, tread is 0.275 square, rise is 0.16 square divided by 0.275. Answer. It will come equivalent in plan. Its value into 3.75 will increase by around 10-12% or 20% more. Answer. Tell me answer. How much? 4 point. Answer now. Magnify it by using the factor. It becomes 4.338. Okay. 4.338 kilonewton per minute. Use this for further calculation. Clear? Use this for further calculation. Clear or not? Use this for further calculation. Don't use 3.75. Use that modified value, 4.338. Clear? Okay. Now, someone will ask me, sir, you told that way correct. Weight of step is not UDL, sir. Yes, correct. It is varying UVL. Correct. No problem. Actually, if the staircase is weight of step is what? It consists of what? This way. This you can replace by UDL. No problem. Second one. Live load comes only here. Then, sir, floor finish. There is a floor finish for rise, tread also is there, rise also is there. So becomes more. Yes, there. That's why floor finish. And sir, the plastering weight. Plastering will come here inclined portion. That all you don't bother. That's why for staircase, when you consider weight due to finishes, including plastering, you take slightly higher side or lesser side. Tell me. And sometimes handrails will be there. Handrails will be there. They are not very major, minor. So considering what? Finishes for tread and rise both, and also what? Handrails and plastering, etc. Ceiling plastering all. When you consider floor finish, consider slightly what? Higher or lesser? What usually comes normal case? Consider slightly what? Don't waste time on equivalent for that one. Consider slightly higher side, that's all. If someone tells exact calculation, then I will take him to task. Exact calculation you want, do it then. I will tell them, how you found bending moment? WL square by 8. Is it simply supported there? No. There is a beam there. Partial fixity is there. Rigid joint. Account for the moment there. That all you are not considering. That all you are not considering. The major issue you are not considering. And jujbi, this small variation you are bothered. So keep quiet. That is the answer I will give. If he answers that question, I have further questions to ask. My questions will never end. Okay. Now we are ready for design of staircase. Only important is how to find effective span is the most important. Effective span. That I will tell simultaneously with our first solution. Clear? How to find effective span, I will tell simultaneously. Somewhere here I solve the question, and side by side I will write here line. I will tell effective span portion here. After the class, whatever I write here, separately make a note. Clear now? Time saving. What happens is, otherwise, numbers you have to take. So, I will start the solution here, then, side by side, IS code provisions, I will tell that side. Clear? Okay. Now, 1 minute. I'll clean the board slightly because my little dust is there. Just a minute. Not much. Half minute. Just half a minute. Okay, cover so that you can't see anything. Just half minute or 1 minute only, that's all. I want a clean board. Just a minute. It is little wet now. It will become dry. And I talked for more than 1 hour, 10 minutes. I'll take 5 minutes break so that energy problem. Okay? Just 5 minutes break. You relax for 5 minutes. Okay? Relax for 5 minutes. I'll come back and start design. Even I should also non-stop shouting. There's a limit. I'll take 5 minutes break. So you also relax for 5 minutes. We'll start now. And remember, I will tell you now itself. This class is for the purpose of building project, not for basic staircase for academic. Basic staircase for academic is I do some other way. Here, oh God, why not activated? 1 minute, sir. Chat section is not on. All voice audible? Tell me. Voice audible? Voice audible? Audible? Little past? Okay. Okay. As I told, this class is for the batch ETABS and SAFE. For them, practical design for buildings or staircase required. I told so many things there earlier. Why you require this class? And there will be lot of approximations here. I will go for practical oriented, not pure theoretical oriented. If it is academic class, I take some other way staircase. This is not the way I take the class for academic classes. Or if it is a basic RCC class, some other way. This is what you require. Others also. But even if you want academic, most of things are same. See, now, I will start here. See, now I will do one thing now. Somewhere here, I will put a line here. So that this side, I will explain effective span. Whenever I require, I will come here. What all I tell here, you write separately. Clear? What all I tell that side, you write separately. Clear now? Don't mix up. When you do the problem, that solve it. Okay, start. See, now, I will go to the most popular type of staircase. So remember, geometric design is not done here. By the time you are ready for building design, staircase plan is already given by whom? Tell me. When you start building design, you already got staircase plan supplied by whom? Supplied by. You don't do geometric design. What is the rise required? What is the tread required? You don't decide. Architect. So, I will take example here. See, imagine, see, this is the staircase room. See, this is the staircase room. There is a beam here, floor beam. And then, see, this is the staircase. And remember now, floor beam may continue. There can be slab here. Here slab is there. Here slab will be there. Don't worry about it. Here slab can be there. Don't worry. Now, see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 threads. Means 11 risers. Then this way. I will not do academic question. Academic question is some other way done. How they give in examination. That way you won't do. Then they will be what? Landing here. Mid landing. There will be beam here also. This is the supporting beams. See, just imagine supporting beam width is 0.2 meter. 200 millimeter. This also is 0.2. This is a beam. See, I will put one thing. Light line, I will have the beam. Just to show, it can be wall also. Wall is not considered. Now, imagine rise is say 150 millimeter, very popular. And tread is, rise means R. Tread is T. Rise I will take 150 mm, 6 inches. Very, very popular. 150 mm. Tread I will take 250 millimeter. That is 10 inches. That is tread. Therefore, and see, this is the width of landing slab, mid landing slab width. I will give somewhere here. Okay. Okay. Anywhere I can give. Here I will give. Width of mid landing slab. Tell me how much? Imagine it is an office purpose or apartment purpose. If it is an office, you require commercial purpose, you need slightly more area. If it is a residential, lesser. Tell some width, landing slab, comfortable width. So that it can be anything, reasonable. How much? 1.5 is not required. Okay, I can take 1.5. Span will become more than. Okay. 1.5. Agreed. No problem. 1.5 meter is landing width. Okay, now, see. If I do academic question, I do like this. See, this way. This way. Here flight. Landing here. No. Practically, this is not landing. What is this one? Tell me. This is what? Here you are at a floor level. When you reach here, you are in the upper floor level. See, you go like this. Then this is called up. And this is called down. You go like this, turn and again go up here. This is down. Now, this is right. And height between floors. Height between floors will be, I have taken 11 risers, 3.3 meter. Height between floors, 3.3 meter. Then, further, I want first, what is this dimension? Tell the answer. See, there are total number of risers. Number of risers equal to 3,300 by each rise is 15, 150. Tell how much? Sometime for some reason it may not be 150. It can be 152 point something. Suppose the height is not a round number. They will adjust it, no problem. See, suppose height is 3.25 meter. Rise will be 148 point something, or if height is 3.35 meter, rise can be 151, 152 millimeter, point something. That is no problem. 22 is the number of risers. That is what? 11 risers in each flight. Clear? I am going for first, this is called dog leg staircase. Make a note. This is dog leg staircase. Okay. 11 risers. And therefore, tell what is number of treads. Number of treads in each flight. Remember, if you got difficulty, you go to a staircase, count and come back. If per flight, for one flight, if 11 risers are there, tell number of treads. Number of treads. 22 risers total. Each flight 11 risers. Number of treads will be always 1 less than number of risers. It is 11 minus 1 equal to 10. Therefore, you tell what is the going. Going is called G. See, this is called going G. Tell the going G. This is what you are seeing is, see, what you are seeing here is the tread. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 treads are there. 10 into how much? 250 millimeter. Or take in meter. 10 into 0.25. It will be 2.5 meter. So this going equal to 2.5 meter. Fully clear? Going is 2.5 meter. Fully clear? Full clear. The horizontal distance in plan for the inclined portion is 2.5 meter. Okay. Now, therefore, now see, how to find, now see, now we want to consider, I will take this as section 1-1. 1-1. This I will take section 2-2. This way, lengthwise section. I write and rub it out. So, how section 1-1 looks? See, there is a floor beam here. So, rise will always start from where? From the edge of the beam. See here, usually. It will be, if I project here down, later sketch I am not giving. If I project down here. Now, start here. This is the floor slab. You come to the floor slab, start, rise. Then, rise, tread. That way I have to go. Again, rise, tread. ಸರಿಯಾಗಿ ಟ್ಯಾಲಿ ಆಗಬೇಕಲ್ಲ ಈಗ 1 ನಿಮಿಷ 2 3 4 ಅಯ್ಯಯ್ಯೋ ಇರಿ ಪರವಾಗಿಲ್ಲ 1 1 2 3 4 5 6 7 8 9 10 ಆಯ್ತು 10 11 ಆಯಿತು. ಲಾಸ್ಟ್ ರೈಸ್ ನಥಿಂಗ್. See this way. Now this is the line joining the edges. Parallelly you can see waist slab thickness here. See here there will be, see what will happen here, there will be a beam here. Here no beam. Usually beam is not given here. If it is given, I will tell you later. This will come this way, then see what thickness is there, you maintain that one. Do not do this way. See, do not draw like this all. Maintain the same thickness here. Okay, done. Here what will happen, there will be a beam here. See, this is a beam. This is a beam here. Here beam will be, this is a beam. Nobody wants beam inside portion here. See, this arrangement. Clear? This beam width is 0.2 meter. This beam also is 0.2 meter. And this total length here is 2.5 plus 1.5, exactly 4 meter. Therefore, the center to center of beams, see, this will become what? Effective span. Effective span or L effective. Tell the answer in meter. Tell the answer from center of the beam to center of the beam. Effective span. Tell the answer. I want to show the calculation. Effective span from here to here is 4 meter. 0.2 there. Effective span. Fast effective span. 4.2 meter is effective span. 4.2 meter effective span. This fully clear? First tell me. Dispatch arrangement fully clear? Dispatch statement fully clear? Okay, now go to right side. How to get effective span? See, in the IS code, they are given some provisions, but little confusion is there. You take what provision I tell here. See, when supported by beams at both ends, L effective equal to center to center of beams over. Center to center of beams. See, because there is no beam here. When supported by beams at the end, both ends, then effective span is center to center of beams. Clear? I will explain further later. Clear now? That is the effective span. Clear or not? No. Okay. Now, once you get effective span, you first calculate slab thickness of slab. Capital D. Capital D can be taken approximately span by, if you remember, tell me the answer. Now, depends upon, is this simply supported or continuous or what? Is it simply supported or continuous? I want to design only staircase slab. This slab I am not bothered. This slab will come in the floor design. See, you can see one, as you enter the staircase, below one beam will be there. You go there, reach the mid landing level, there is a beam there, supporting beam, come take a U-turn and then again go up next beam level. It is actually not simply supported. Remember, make a note here. If I see along the length here, see, if I put inclined portion here, see, there is a beam here. It goes this way, then this way. There is a beam here. Actually, it is monolithic with the beam. Yes or no? It is, see, monolithic with the beam. And here also, when the beam is there, there is continuity here. There is continuity here, and here it is monolithic. Tell yes or no? There is a continuity here, and there is monolithic. These all you have to remember. I am going for practical design. not academic design. My class is for ETAB and safe batch. Others get benefit if you understand. Yes. Therefore, there will be a reacting moment here. There will be some reacting moment here. Remember. But what happens is, this is inclined. This is this way. It is not purely continuous, or it is not fixed. This hogging BM at the ends, by chance, if ignored, then tell me now, if there is no, if the see, by chance, if the staircase is just simply supported, see here, if it is only simply supported, it will sag this way, sag here. Now this is pure simply supported. Now because of the end moment, what will happen? There will be some hogging here, some hogging here. So as a result of that one, see, this way. Therefore, tell me, the real sagging will increase or decrease? The real sagging will increase or decrease? Because of the end moments, the real sagging will increase or decrease? Will decrease. The real sagging will decrease. But practically, nobody considers it, because this is not a high value, it is a low value. Maybe some 10-12% it may decrease. But however, for safety, you ignore the end moment. Then you get what? If you ignore the end moment, you will get sagging more. Designed for higher sagging, safe or unsafe? Designed for a higher sagging, safe or unsafe? For sagging BM, safe or unsafe? Safe. Then somebody will tell, sir, you are designing for sagging, sir. Hogging is there. No problem. Afterwards, there will be top reinforcement here. Clear now? Afterwards, there will be top reinforcement there to take care of hogging BM. Clear or not? So even though we are designing as simply supported for easy understanding, see complications, but there will be some hogging here, some hogging here. Because of the hogging, what we will do? Because of the hogging effect there, later, see, sagging will reduce. We are designing for higher sagging bending moment. And for hogging BM, whatever bottom steel you provide here, same top steel also you provide. So you are providing high hogging steel. So it is safe. Practically, all are doing like this. And then, one important aspect, tell me, deflection control. Tell me, because of the hogging, deflection will be more or lesser? Tell me. If it is pure simply supported, remember, then what? If it is pure simply supported, then that constant is 20. Because there is partial fixity and continuity. And one more thing, see, staircase is not like this. Staircase is like this. When it is like this, deflection becomes more or lesser. See, if it is a single line, this is a deflection. But when there is a junction here, tell me, the junction, will it increase the deflection or decrease the deflection? That junction and also end conditions, will it increase deflection or decrease deflection? Decrease deflection. Therefore, for deflection control, you can take continuity is there. Continuity is there. If continuity is there, tell the number. Tell the number. If continuity is there, tell the number. Not 20. What is the number? If continuity is there, basic number. 26. Sorry, 26. Therefore, L by D should not be more than 26 into modification factor, or your D required is what? D required is what? L by 26 into modification factor. But modification factor we are not knowing. You can assume around 1.3 to 1.4 approximately for staircase. So if you assume 1.3, Tell the answer. 26 will become, or if you assume 1.3 to 1.4, tell me, or say 1.35. 26 into 1.35, what is the number? This all I told you earlier. 26 into 1.35. 26 into 1.35. Ayo, 26 into 1.35. No reciprocal number. 26 into 1.35. 35.1. You can take approximately 35. Remember, long back I told, for simply supported, you can take span by 25 to 30. For continuous, you can take around 30, 35 or 40, in that range, depending upon the fixity. Remember it? Long back I told, simply support you can take 25 or 30. Continuity is there, you can take around 35. Remember it? Yes. So I told in the batch, so you can remember, span by 35, approximately, tell the answer, 4200 by 35. Answer. 4200 by 35 will give you approximate D. Approximate D. Actually small d rounded to capital D. Or you can do one thing. For safer side, tell what? Tell me. Or safer side, take what? Safer side, not 35. Take what? Safer side, take what? Little what? Safer side, if you take 35, thickness may come lesser. Safer side, take practically 30. 1 minute now, I will calculate. See, okay, no problem. See, if I take 35, it comes to 120 millimeter, correct? If I take 35, it comes to 120 millimeter. Yes or no? Tell me. If I take 35, it comes to 120 millimeter. Yes. If I take 30, it will come 140 millimeter. So tell me, span is around 4.2 meter. 150 mm thickness better or 125 better? Think a little. Span is 4.2 meter. 4.2 meter span, 125 better or 150 better? Think a little. 150 better. So take 30, still safer side. How much? 140 millimeter, round off. Therefore, see, try capital D 150 millimeter. Clear now? This step is clear. Try capital D 150 millimeter. Clear or not? And one more thing I forgot now. Loading I will tell you. Take 150 millimeter. Now, you decide what is the diameter of the bar. See, maximum permissible bar diameter as per IS code. Bar diameter equal to 1/8 of 150. What is the answer? You should not use the bar for slab more than 1/8 of the diameter. Not permitted. You cannot use a diameter more than 1/8. How much answer? Maximum permissible bar diameter 18.75. 18 we will not use. Okay. Now, let us take, tell me, what diameter? Tell me. Now, very important concept. 4.2 meter span. Loading is going to be more than usual slab. Yes or no? For staircase, loading is going to be more than usual slab because self weight of staircase is to be converted, then weight of steps are there, etc. Loading is more. On those reasons, better take in the beginning higher diameter or lesser diameter. I told you, if you take a diameter, later if you are changing, if you decrease the diameter, well and good, no problem. Your D will become more. But in case you have to increase the diameter, problem will come. Better take higher side. We will do one thing. Say, for this staircase, I feel 12 tar is okay. Clear? You write there. I think 12 tar is okay. Clear or not? I think 12 tar is okay. I feel 12 tar bar can be managed. But still, tell me, for to be on safer side, later I do not want trouble with the D. I will take, let us initially assume, let us initially assume diameter of main bar, tell how much, safer side, for margin, let it be there, later safe, no. How much? I will not take 12, how much I will take? For safety, later I do not want redesign, for 16 mm, so that later if you reduce, well and good, 16 mm. Okay, now, minimum clear cover. Remember, moderate, mild exposure for slab 20, for beam 10 more stirrup. Here slab, clear cover, we will take 30 mm. Means what? That is moderate exposure. Therefore, tell what is the effective depth D provided, equal to 150 overall depth minus clear cover 30 minus half the diameter. If anybody tells, sir, this step is not clear, means don't come to RCC class. When you come to this staircase design, slab design, 1000 times over. Even those who joined late, I have sent the recording for you. Yes or no? Even those who joined late, I sent the recording of all the previous classes. There you can see all this. How much answer? 112 millimeter is the effective depth. Okay, now, very important, consider, now see, next step is load calculation. Load calculation. For that, very, very important, consider 1 meter strip. Strip is very, very important. 1 meter strip, where, see, this way, 1 meter strip of the slab. Start. First, self weight of waste slab. Self weight of waste slab equal to whatever is the slab thickness, 0.15 into 25. Answer. It will come in kilonewton per meter square. That will give you self weight of the waste slab. Answer. 0.15 into 25. 3.75 kN per meter square. Okay, then immediately do one thing, calculate equivalent of this load in plan. Equivalent of this in plan equal to directly 3.75 into square root of, I told you, tread square plus rise square, 0.25 square plus 0.15 square divided by 0.25. I told you very clearly earlier formula, kilonewton per meter square. Answer. Now this is cancelled, this will come new value. This value is modified now. See, equivalent in plan. Whatever you got there into root of tread square plus rise square divided by tread. How much? This is the equivalent load in plan. 4.373. 4.373 kN per meter square. Now you calculate weight of steps. Remember, tell me, this is dead load or live load? Very, very important. Tell me, this is dead load or live load? Very important. Because in the ETAB, dead load, live load, separate assignment. This is dead load. Remember, this is dead load. Now, weight of steps equal to, remember, I'll give a note for you. Weight of steps equal to, see, depth into density. Depth into density. Usually for steps, plain concrete used. Therefore, density is taken 24 kN per meter cube. And depth means rise. Yes or no? Depth means rise. See here, this is the tear. See, now, this is how it goes. See, this weight is already over. Now, this is the rise R. Depth is rise. Clear? Okay, but one thing, since it's already over, here full rise. As you go here, rise will become lesser 0. Therefore, since the rise varies, rise but take average rise. Average rise. That is 0 r plus 0 divided by 2 or r by 2, or remember, self weight of steps is always equal to rise by 2 into density. Clear? Per meter square. Rise by 2 into density. Clear or not? Here I won't waste time. I will put out rise is, see, rise equal to 150 millimeter. Therefore, 0.15 by 2 into 24. Direct here. No story here. Clear? Rise by 2 into density is the self weight of steps. Okay. Answer. How much? 0.15 by 2 into 24. Answer. Not 25, 24. 1.8. ಸುಳ್ಳು ಹೇಳಬಾರ್ದು. I think 1.8. Check ಮಾಡಿ. 0.075 in 24. 1.8. Okay, 1.8. Okay, now this is, tell me, this is dead load or live load? Tell me, weight of step is dead load or live load? Weight of step is dead load or live load? Dead load. Okay, now other dead load. What other dead load? See now, weight due to finishes, comma, plastering, comma, handrails, etc. All together you round off in kN per meter square. See, depends upon the thickness of the tiles, density you require. Then it comes for rise and also for vertically tread, little more weight will come. Plastering is not a major issue. Handrails. Usually for building slab, you take finishes around 1 to 1.25. For staircase, take little higher side. Tell the answer. Don't argue all these things. Little liberal. Tell little higher side. How much? Usually building floors, 1.25 like that. Little higher side. Little higher side. So that safer side. 1.5. Okay, agreed. 1.5 kN per meter square. This also is dead load. Correct? This also is dead load. Okay. Now, therefore, see now. This I will remove now. Even effective span portion I will remove because I will continue later. When I want effective span, I will continue later, write separately. Now, see, consider effective span. See, actual admission. Now do one thing, not consider. Now BM calculation. Okay. See, actually, I will put here, your staircase is like this. Tell yes or no. Now tell me, from here to here, tell the length. From center of support to the junction, tell the length. From center of support to this junction, tell the length. Center of support to junction, tell the length. Correctly observe the plan. Center of support junction. This is 0.2 meter. Going is 2.5 meter. 2.5. Adenge 2.5 is the clear. How 2.5 meter? How 2.7? How 2.7? This is 2.5. Support is 0.2. Center of support. How many corrections? Center of support. That you should be able to calculate. I don't have to explain. 2.6 meter. This is 2.6 meter. Tell me, what is this length? You can see here. From the outer edge to center of support here. How much? 1 point. What is that? 1 point. 1 point. 1.6 meter. Okay. 1.6 meter. Okay. Now tell me, so total span is what? 4.2 meter. Tallying now. Tallying or not tallying? Effective span is 4.2. Tallying? Tallying or not tallying? Effective span, if you add those two, you get back 4.2 meter. Tallying. Now, see here. Here, there is a loading. Load is vertical only, but here little lesser load. Tell me what is this load, what is this load for dead load I want. Dead load I want. Tell me. Dead load here. See how to calculate. 3.75 cancelled. Instead of 3.75, how much you have to take? Tell me. Instead of 3.75, how much you have to take? You can't take 3.75. How much you have to take? Instead of 3.75, how much you have to take? You cannot take, see, inclined portion it is. Instead of 3.75, you have to take 4.375. That is the equivalent load plus then weight of steps 1.8 plus finishes etc. 1.5. Tell the answer in kilonewton per meter square. These all, remember, once you go to practical, these all will not take more than 2-3 minutes. This is to understand. 2-3 minutes, that's all. Once you understand, you don't write this way. There are people with the minimum structural knowledge, they do very fast. Why? Mechanical. Answer. 7.675. 7.675. Remember, here you should be careful. Why? Here you should not take 4.373. How much you have to take? Tell me. Landing portion, there is no equivalent. For landing portion, you should not take 4.373. How much you have to take? You should not take 4.373. How much you have to take? You should take 3.75. This is 3.75 direct self-weight. Direct self-weight plus others are same. And remember, for landing slab, step weight is not there. Clear? Weight of steps are not there. I think that should be clear. There is no steps there. Clear? No steps there. Not clear? No steps there for landing. Yes. So only finishes 1.5. Tell the answer. 3.75 plus 1.5. I will tell you systematically, then I will tell you practically what to do. Remember, this class is for practical knowledge, not your academic knowledge. Some people will tell, how you can take that way? I am taking that way. Keep quiet. Answer. Add those two. I am writing only dead load. Add those two. It's 5.25. Okay. 5.25 is here. 25 kN per meter square. Then, now I want live load. Same way, I want live load. Live load is everywhere same. How much? Tell me. Everywhere same. How much? This one and this one, both how much? Live load. See, how much live load? Tell me. If it is residential building, how much you can take? Fast. Imagine residential building around. Don't take high value. Residential building, live load. Residential building, around 2, 2.5, etc. Imagine our building is commercial building. So imagine it is public office or commercial. Therefore, live load, I will take 4 kN per meter square. Right there. 4 kN per meter square here. Here also 4 kN per meter square. Clear? Write clearly. Why 4? I am going for, I want critical case. If it is a residential building, you are safe because bending on will come lesser. Clear? I will take 4. Clear 4? Why I took 4? I will go for commercial. Or depends upon the, that all you don't bother now. In the question 4. Now, therefore, what you have to do now is very important. See, now, for a dead load and live load, we want load transfer. See, first, load transfer. Load transfer to what? Tell me. Load transfer to what? This is a practical class. This is what is important for you. When you do the building model by ETABS, staircase load, you have to transfer to beams. Tell me. Load transfer to what? Load transfer to? To which one? Staircase load transfer to? Which one? Beams. Load transfer to supporting beams. To supporting beams. For that, see, right, even though it is inclined, now load is vertical, length is horizontal. Someone will tell, this is more length. It is more length, that's why we magnified 3.75 to 4.373. Therefore, now the length is only 2.6, correct or not? Now the span is only 2.6 because this 7.675, 4.375 is for 2.6 meter only. Clear? Important concept. Now the span is clear or not? Now no inclined length. Tell me, clear or not? Now no. Therefore, what you can do is you write one sketch here. See, this way, visible, board visible fully. Let me see. Is the board fully visible? Oh, okay, visible. One sketch there and put one sketch here. Here, for a length of how much? 2.6 meter, 2.6 meter, and then remaining length of how much? 1.6 meter. Here you write load of 7.675 kilonewton per meter square. Here you put lesser weight of, or 1 minute now. Shall I remove all these and put a bold sketch actually? Shall I remove all these? Put bold sketch. Tell me. Shall I put bold sketch? Yes. One more thing. By chance your slab thickness 150 is unsafe. If you are redesigning, then these values I will redesign them. No problem. So don't waste space here. See. Not space. I want bold sketch because important concept comes down. Practical design. When you do building project, you should know all these things. I will tell you a little later how fast you can do it. Okay, start. See now. Now, for dead load, you take here. How much? This is 2.6 meter. This is 1.6 meter. Load is 7.675 kilonewton per meter square. Even if it is 1 meter square, it is per meter only. And this is lesser. 5.25 kilonewton per meter square. I will take this as A and B to understand. A, B, their support name. Okay, now this is for dead load. I want what is the support reaction. What is support reaction? Tell the answer. Support reaction. Here, to get support reaction, I will take this as VA, I will take this as VB. Then, sigma m about A equal to 0. Take clockwise positive. Minus VB into 4.2. Full span is 4.2. Plus 5.25 into 1.6 is the load into 2.6 plus 1.6 by 2 is for this UDL plus 7.675 into 2.6 into 2.6 by 2 is for this UDL equal to 0. Tell correctly VB, it will give reaction in kilonewton per meter. That actually kilonewton per this way meter. Answer. It will give kilonewton for 1 meter supporting beam. First answer. Which lecture? Where I can see lecture means which lecture? I don't know. Someone asked the question there, where I can see which lecture. You should tell which lecture you want to see. If you simply ask lecture means which one. Answer first. Don't waste time. Give correct reaction. Don't give wrong value. I told you I am going for practical oriented class. Is it 12.977? 12.977. 12.977. Now, sigma V equal to 0, take upward positive. Plus VA plus VB minus 7.675 into 2.6 only loads minus 5.25 into 1.6 equal to 0. Tell the value of VA fast. VA value. Tell the value of VA. Don't worry. I am going to reduce all these things to one line for those who are doing project later. These all I will go to one line. But first you should understand. VA, how much? I will reduce it to one line. We have a little patience. Then you will tell, sir, so easy. Yes, but so easy because you understood this one. 15.378. 15.378 kilonewton per meter. So I will enter the value here. VB equal to 12.977 kilonewton per meter. VA equal to 15.378 kilonewton per meter. This is for dead load. Okay, now wait for some time. Some will tell, sir, this is too lengthy. No, wait for some time. Now consider live load. Live load, you don't have to show the junction. Simply show what? A load of 4 kilonewton per meter square. Span is 4.2 meter. Tell the answer directly. Total load divided by 2. This way and this way will be equal. Tell the answer. 4 into 4.2 by 2. 4 into 4.2 by 2. Answer. 4 into 4.2 by 2. 8.4 kilonewton per meter. 8.4 kilonewton per meter. Okay. Therefore, tell the answer now. Okay. See now, I am removing this one now. Therefore, see, therefore, during ETABS modeling, see, there is a beam here, and see, I will put the beam on meter, I will put name here. This beam I will call P, Q, R, S. See, P, Q, R, S. For the beam PQ, tell what? For the beam PQ, it is like this. For the beam RS, this is P, this is Q. This is R, this is S. Clear now? PQRS. Clear or not? Clear? During ETABS modeling, see, there is a length of, see, now this length required. I don't know what is this length. Tell me, what is the length you will consider? Tell the answer. Comfortable length, not half meter like that. Quite wide beam, wide staircase. How much? Don't tell 3-4 meter. Tell me answer. What is the width you will consider? It is not coming for design. It will not come for design. For beam it is required. 1.5 meter. Okay. Imagine 1.5 meter. 1.5 meter. So 1.5 meter here. I will put here now. See, these two are 1.5 meter. Remember now, I will tell you now only. See, correctly see what I am telling now. Write it correctly. Clear or not? Write it correctly. What I am going to tell PQRS, I will tell dead load application, and then I will tell live load application here. This is for the project. What I am telling, see correctly now. Those who are in the group, see correctly. Clear or not? What I am going to tell, you should write everything. Agreed? You should write everything. What all I am going to tell, you should write everything now. You are not agreeing. Okay, see. Load is this way, assigning UDL. You ETABS modeling, assign UDL. Tell what UDL. See, your PQB may continue here. It may continue here. It may continue here. It may continue. We are not bothered about that one. We want assign slab load. If the beam has got local origin somewhere else, you know how to apply partial UDL. You want load from here to here. If the origin is here, you know how to assign UDL. Yes or no? Starting and ending point of UDL, you know based on local origin. Yes, you should know that one. Here, see. Now, very, very important. See, suppose it is mid-landing level. Mid-landing level, this beam, RS. Then, what? Dead load of, tell how much, tell me. From R to S, assign dead load of, how much, tell me. If it is mid-landing level, assign dead load of, how much, tell me. R to S, assign dead load of. See the sketch there. See the reaction here. This is for meter length. 12.977 kilonewton per meter. And this is for mid-landing beam. Everywhere same. And assign live load of how much? For the contact length here, for what length staircase is in contact with the beam, for that contact length, assign live load of how much? Assign live load of how much? Tell the answer. See the answer here. Reaction. 4. 4 is in K per beam reaction. 4. 4 Kn per meter squared. Span is 4.2. Load transfer to beam. How 4? 8.4. Fully clear? Mid-landing beam. Fully clear or not? Any level mid-landing beam. Fully clear? Now what I am telling, right? This will not change. Now, suppose it is first floor level. Tell the answer. Suppose it is first floor level. What will happen? First floor level. Here, flight will come. From here, flight will go. Therefore, if it is first floor level, assign how much? Here or here? First floor level. How much assign? Tell me. How much? Assign, see why? Because first floor level, here, see, this flight will come and next flight will start. See here, first floor level. One flight will come and stop here, next will start. Both sides loaded. Clear? But remember, if it is the plinth beam level, base level, plinth beam level, suppose imagine plinth beam level, imagine staircase in the base has connected to plinth beam. Suppose no plinth beam, no problem. Why? Separate footing is given. If the ground level, if the staircase is not connected to plinth beam, they will connect to ground by foundation. Clear or not? A small foundation will be there. Clear? If the staircase and the ground If it is not connected to plinth, a separate footing will be there. Then no problem. No, it will not come in the ETABS frame. But if plinth beam is there, assign the load only on this side, see, back side or front side. If it is plinth beam level, assign load of 15.378 dead load and 8.4 live load on the back side or front side. If it is a plinth beam level, tell me, plinth beam level, base level. See, intermediate level, one floor, one flight ends, other side, one more flight starts. Back side. Now tell me, if it is the terrace level, where staircase stops, if you go to terrace level, then assign these two loads on the back side or front side as per this sketch. See there, flight goes this way. When you reach terrace level, when staircase is not there, further continuation, then assign this load on which side? Front side. Fully clear? Building project point of view, full clear or not? Fast. Full clear or not? I will tell practically what they will do. And no front, no back. What they will do? Everywhere assign full. Correct? I will tell assign 15. Front or back, assign 8.4. Little safer side. Now, correct? Okay, this is the load transfer. Now, I will tell you something. See, correctly. Now, load transfer clear now? In the building model, load transfer clear. I will go you further shortcut. I will make it very easy for you now. I will make it very, very easy for you. Okay. Now, our purpose is staircase design. I will remove this one now. See. Now go to bending moment calculation. See. Now, we want now slab design. Slab design you are doing. For that one, you need what? Dead load plus live load. Yes or no? When you assign the load to software ETABS model, dead load separate, live load separate. But when you design the slab, you should design for dead load plus live load. Yes or no? Tell me fast. You should design for dead load plus live load. Yes or no? Fast, tell me. When you design 1.5 later, 1.5 later, dead load plus live load. Okay, therefore, what you do is dead load plus live load, if you write, the beam will become what? For 2.6 meter and then remaining 1.6 meter. There will be a change. Here, the dead load plus live load is, tell the answer, 7.675 plus 4. Answer. 7.675 plus 4. 675 plus 4 equal to 11.675 kilonewton per meter square. Here the load will be how much? 5.25 plus 4. That is 9 kilonewton per meter square. Even reaction not required. Reaction equal to 15.378 plus 8.4. Tell the answer. 15.378 plus 8.4. Add the reaction. 15.378 plus 8.4. Tell the reaction here. 15.378 plus 8.4. Tell the reaction. Tell fast reaction. Don't worry. After some time, I will tell you one line how to do it. I will tell you practically one line. But remember that you understand only to understand all these things. Answer. Or once again take moment. 15.378 plus 8.4. Answer fast. See, you are delaying. Delay means problem. 23.778 kilonewton per meter. Resultant reaction VA. Same way, resultant VB. How much answer? It is 12.977 plus 8.4. Tell that answer also. 12.977 plus 8.4. 12.977 plus 8.4. ಎಷ್ಟು 21. ಸುಳ್ಳು ಹೇಳಬಾರ್ದು, 377 kilonewton per meter. Now we want maximum BM here. Tell me, this is symmetrical case or unsymmetrical case? This is symmetrical case or unsymmetrical case? Do not worry. After some time, I am going to give you one line answer. You have some patience. Symmetrical or unsymmetrical? Unsymmetrical. Therefore, if you want maximum BM, first you have to draw shearing force diagram. Okay, I won't ask you, I will draw it. Why? I am quite good in shear force diagram. ಲಿಟ್ಲ್ ಮೋರ್, ಒಂದು ನಿಮಿಷ, ಅಷ್ಟೊಂದಲ್ಲ, ಲಿಟ್ಲ್ ಮೋರ್. ಓಕೆ, ಸ್ವಲ್ಪ ಸ್ಲೋಪ್ ಕಮ್ಮಿ ಆಗಬೇಕು, ಲಿಟ್ಲ್ ಸ್ಲೋಪ್ ಲೆಸ್ ಸರ್. ಓಕೆ, ಸ್ಟ್ರೈಟ್ ಲೈನ್, ನೈನ್ 9 plus 5 is 9.25. Where you are? N per meter square. Okay. Now, this point is the point where bending moment is maximum. So, this distance you require. It will be these all remember SFD BMD. I cannot waste time here. You are supposed to know all these things. You should be better than me. 2.0367 meter. Now your maximum BM, I will call the point X, equal to bending moment at the point X equal to reaction plus sagging positive. 23.778 into 2.0367 minus, how much it is? 11.675 into 2.0367 into 2.0367 by 2. That will come leave it now. 24.21 kilonewton meter. Check the answer fast. 24.21 kilonewton meter. Check the answer fast. Now I will give you shortcut. Now I will give you real answer. Now you will tell, sir, why so easy? You will tell later, sir, if so easy, why you did all these things? I did all these things because you should know correctly how it comes. Otherwise, tomorrow somebody will ask doubt. Yes. Answer tally. Is 24.21 comes? Is 24.21 comes correctly? Tell yes. You should tell yes means what? You should tell tallying 24.21. Correct. Okay. Now, do one thing. This is the maximum BM. Remember, it is for working law. Maximum BM. Okay, leave it now. Now, shall I tell the shortcut? Practical what to do? Shall I tell the shortcut? Tell me fast. Shall I tell the shortcut? Some will tell, sir, so easy. Shall I tell the shortcut? Yes, see now. And now, you all stay there. I will come here. I will come here, okay? Okay. I will do one thing now. See. Once again start. Once again start. Nodi. Capital D equal to 150 millimeter. With 16 torr, small d equal to, what is the value you told? 150 minus 30 is 120. Is it 100 and, you forgotten. 150 minus 30 minus 8. 112 millimeter. Okay. Small d is how much? 150 minus 30 minus 16 by 2 is 112 millimeter. Okay. Then loads. Self weight of waste slab 0.15 into 25. Answer. How much? Tell me. First answer. See, this is what you do practically. This is what you do practically. Don't do these things. Now you will tell, sir, so easy. Tell the answer once again. Tell the answer first. 3.75 kilonewton per meter square. Tell me. Equivalent in plan. How much? 3.75 into root of t square plus r square by t. Answer. Equivalent in plan. First answer. This you have to calculate. 250 square plus 150 square by root, then 2 divided by 250. Equivalent in plan. Once again. 4.373 kilonewton per meter square. Then over. Then weight of steps. Weight of steps. 0.15 by 2 into 24. 1.8 kN per meter square. Then finishes all. You have taken 1.5 kN per meter square. So all together dead load is how much? Tell me. 4.375 plus 1.8 plus 1.5. Answer. Dead load. Dead load on the staircase slab. Answer. Per meter square. Dead load. Dead load. 4.375. Don't take this one. Take 4.375. 373. 4.373. Its answer is there already. 7.675. Live load. How much? 4 kN per meter square. Now, see, write something. What I am telling. What I am telling, right here. Agreed? Little confidential. Actually, this is a public class. I should not tell here because this is a public class. If it is a Zoom class, I can tell because only you are there. This is a public class. Still no problem. Somebody may hear and he may argue with me. If he argues with me with 1 point, I will hit back with 1,000 points with him. If somebody finds a mistake, yes, I agree, some approximation. If he tells 1 point, sir, this way, I will tell, come here first. Let us discuss so many things. Then he will tell, in future I will not comment. Okay, right. This is the dead load. 7.675 is the dead load where weight slab is there or not there. Answer. 7.675 is the dead load where weight slab is there or not there. You have to write all these things. Do not see anything of this one. See, I am doing fresh now. Do not do anything of this one. 7.675 is the dead load where weight slab is there or not there. Answer. It is where inclined slab is there or not there. 7.675 higher side is there. In the landing, load becomes slightly what? In the landing, load becomes not 7.675, it will become slightly what? Tell me. Slightly less, more. Yargappa more adu? Ayyo, Suresh. More. Their steps are not there, directly planned. Less. You write less or more or nothing. We don't bother. From to where flight is there, load is 7.675, and where landing slab is there, it is little lesser, 5.25. Ayyo, once for all settlement. Dead load. See, how much? Tell me. How much? How much? Tell me. How much? Tell me. How much? Full, actually, little lesser here. Well, leave it, I said, no problem. Building project. We can't do these things all. No time. How much? How much? People do this way. How much? 7 point. Huh? I am telling 7.673. Okay. 7.673 where landing inclined portion is there. Other portion, you are going, no, I am asking you, where inclined portion is there, more weight. 7.675 adu. It is 675, I think, correct? 675 or 673? 675. 7.675. Okay. Where landing is there, little lesser. Tell me what? Little lesser, we don't bother. You tell everywhere same load. How much? Tell me. 7.675. Reaction fast. Reaction. 7.675 into 4.2 by 2. 7.675 into 4.2 by 2. Fast answer. 7.675 into 4.2 by 2. No question of taking moment, nothing. 16 point what? 117 kilonewton per meter. 16.117 kN per meter. Then live load 4 kN per meter square. 4.2 span. Actually, remember, your bending moment came how much? 24.21. Remember what BM you got? Okay, start. Reaction. 4 into 4.2 by 2 over. 4 into 4.2 by 2 over. No question of bargaining. 24 into 4.2 by 2. 8.4 kilonewton. 8.4 kilonewton per meter. 8.4 kN per meter. Therefore, for both the beams, transfer dead load of how much? Tell me. For this side beam and that side beam, for both the beam, transfer, apply ETABS model. In the ETABS model, for both the beams, actually, both the beams, assign dead load of how much? 16.117. Actually, one of them is 15, other is 12. Instead of 15 and 12, assigning 16.117, safe or unsafe? Tell me. Who will bother about these things? Safe or unsafe? Both the beams assign same load. Safe or unsafe? Assign maybe little lesser. 16 you can make. Safe. Live load for both the beams assign how much? Both the beams assign. Live load, both the beams assign. Both the beams assign. No. 8.5 or 8.4 adu. 8.4 kN per meter. Some will tell 16.115, make it 16.5, 8.4, make 8.5. Agreed? Okay, done. Now, so clear now? You don't have to struggle all these things. You find weight of the inclined portion, convert to plan, take that as everywhere. Clear or not? Inclined portion, what load comes, convert to plan, higher load, take everywhere same. Clear or not? Clear. Then add other things. Dead load, live load, divide by 2, assign. Then, now ETABS problem over. ETABS modeling problem over or not? ETABS problem modeling problem over. Tell me. For ETABS modeling problem over. Load from staircase. ETABS modeling over. Now what you require? Now you should design manually which one? You should design manually which one? Okay, ETABS portion over. Now lastly, you should design manually which one now? No ETABS. Manually you should design what? Waste slab. For that, tell the answer. Working load, tell the working load. Working load is what? Dead load plus live load. How much? 7.675 plus 4. Answer. Kn per meter square. W. Dead load plus live load answer. No lesser, yeah. See, Wada. Go. Answer. This is what you can do practically. Safer side. Answer fast. You are wasting lot of time to sum up the two values. I can do myself only. 7 నాకు హన్నుందు 11.675. Okay, now both UDL, tell me maximum BM. Now no formula. WL square by safer side, ignore fixity, simply supported. WL square by chapter closed. WL square by how much? This is what all are doing. WL square by how much? 8. WL square by 8 equal to 11.675 into 4.2 square by 8. Answer fast. WL square by 8. That shear post diagram here equivalent, there separate. I will tell you now, 1 minute. 25.75. So if you do this way, see now, what you do is, see now, write it. Decide slab thickness, self weight of slab, that thickness in density, weight slab, convert to equivalent to plan. Okay, done. Some answer. That is dead load. Add weight of steps, add floor finish. W will come. That's all. Full UDL. That into span by 2 reaction. Transfer to beams. Live load 4 kN per meter square into span by 2. Transfer to beam. ETAB, you go now. Now, manual design of slab. Self weight of slab converted to equivalent plus slab weight of steps, finishes plus live load, add all. You get 11.675. WL square by 8 will give you 25.75. If you do this way, tell me, is it very, very uneconomical or reasonable? Instead of designing for 24.21, you are designing for 25.75. Is anybody will object? Instead of designing for 24.21, you are designing for 25.75. Tell me what? Is it a serious offense or safer side? Agreed. Suppose cross-checking comes. He will tell, if you do rigorous calculation, how much you get? 24.21. How much you considered? 25.75. Is it? It is safer side. And is there too much variation? Is there? Tell me. This way if you do, is there too much variation? Is there too much variation or small variation? Is there too much variation? Small variation. And small variation, that too on what side? Safer side or unsafer side? Small variation, that too on safer side or unsafer side? Safer side. Therefore, what you will do is, these all will cancel. None. This is there. As soon as you get this one, you got M equal to WL square by 8. Your W is what? 7.675 plus 4. L is 4.2 meter. You got the answer. 25.75 kilonewton meter. Now proceed further for slab design. Strictly speaking, I should stop here. Yes or no? Strictly speaking, I should stop here. Yes or no? Tell me. Strictly speaking, I should stop here. Yes or no? Tell why yes. Tell me. Why yes? Why yes? Strictly speaking, I should stop here. Why yes? Reason. Why yes I can stop? Reason. Why I can stop? Reason, I won't stop jet lag fun. I can stop here. Reason, why I can stop? You know how to continue. But still, since it is a class meant for public also, briefly I will continue. But remember, again, non-stop talking. 5 minutes break. Oh, agreed? 5 minutes break. I will come and continue here. Then I will give one more revision for you. Then I explain other things for staircase. Okay. Then I will tell some important concept for practical design. Okay. Just 5 minutes break. Because I am also a human being. I start. Break sufficient. Just made somebody asked a comment there. It is not required to answer. He told this playlist ETABS classes available from class number 24 onwards, where I can see previous lectures. You cannot see previous lectures because this is a group or a batch for ETABS and SAFE. First to 23 classes, that is around 23 into average 3 hours. Around 60-hour classes, that is for introduction, basic of structural design, and very important shear post bending moment, then beam design, slab design. They all covered for the group only for those who joined my batch. When it came to columns and footing, I thought, okay, let the public be benefited. So therefore, those classes you cannot see. It is only meant for those who are in the group. And here also, see, today's ETABS class number I told 41. This is not 41, 45, 46. It is actually not 46. Second round 46. 45 classes are for software. These are taken for the group only. Only staircase portion, I thought, let public be benefited. So you cannot see it. You cannot see it. It is only for those group. Whatever I give for public benefit, you can use it. Okay. Okay, now start the slab part. See. Now remember now mechanical steps. Tell me. Shall we design for 25.75 or 24.21? Tell me what? Shall we continue for 25.75 or 24.21? Shall we continue for 25.75 or 24.21? 25.75. Therefore, remember, maximum BM maximum BM equal to how much? Equal to, we will take safer side. See why? You do not want to waste the time. 25.75 kilonewton meter for 1 meter strip. Over. Start. Therefore, start. First to calculate MU limit. MU limit equal to 0.36 into XU max by D into bracket 1 minus 0.42 XU max by D into BD square into FCK. Remember, we are using we will use M25 concrete plus FE 500 steel. For FE 500, your Fy equal to 500 Newton per mm square, and you should know that XU max by D equal to how much? These are all RCC part thoroughly covered with the real meaning of each term, not simply formula. Everything covered with systematic way for beam design. How much XU max by D? For FE 500 steel, XU max by D, you should tell with no time, 0.46. Okay, 0.46. Therefore, your MU limit equal to 0.36 into 0.46 into 1 minus 0.42 into 0.46 into FCK is 25, B is 1000, Y width is 1000, D is 112 square into BD square into 1000 into 112 square into 25. This will come in what? It will come in Newton millimeter. Convert and tell me in kilonewton meter. Answer. It will come in Newton millimeter. Divide by 10 to the power 6. Tell me in kilonewton meter. How much? MU limit. 41.9. 41.9 kilonewton. Therefore, your MU is less than MU limit. Yes or no? Tell fast. Therefore, cross section will be singly reinforced. Correct? Yes or no? Tell fast. Yes or no? MU less than MU limit. Therefore, single A in post. Tell fast. Yes or no? High speed. No wait. Yes. No. This is the dangerous part you are doing. And remember, in the old classes, in the beginning of the course, that is I told you that up to class number 25 or 23 or 24, how many times I told, this is the bending moment for what load? Tell me. This is for what load? 25.75 is the bending moment for what load? Abba, you still make the mistake. It is for what load? 25.75 is the BM for what load? This I shouted class after class. Not once. This is for working load. Working load. Therefore, you calculate factored maximum BM. That is called danger. If you forget this step, there is no excuse for you. MU equal to what? 1.5 into 25.75. What is the answer? 1.5 into 25.75 kilonewton meter. What is the answer? This step you made mistake earlier. I was first showing my irritation. I started scolding also. I told one day, if you do this way, it's a criminal mistake. Working load BM you cannot take for limited method. You should increase the BM. Did not I shouted earlier classes, basic classes? Did not I shouted class after class? Tell me. Did not I shouted class after class? Tell me earlier. Class after class, shouted like anything. Be careful. I even showed the finger also. See, be careful. If you forget this step, it is a criminal offense. Why? Because you are allowing the structure to collapse at working load. You should allow the structure to collapse at factored load. Most dangerous. You are forgetting safety margin. Now don't make the mistake. How much? It is 38.6. 38.6. Children badabadi. 63 kilonewton meter. So your MU is 38.63. Limit is 41.9. Therefore, okay. Correct? Sometime it is possible. You want a newcomer. He may comment in the comment box. Sir, mistake. What mistake? Sir, you are taking working load BM as MU. I will tell him. Why I left the gap there? See the gap there. I showed a red mark there. Why? To show you that I know that one. See, why I left a gap there? Sometime, if it is an offline class, when I leave a gap and write, student will tell in Kannada, ಏನೋ ಬತ್ತಿ ಇಟ್ಟಿದ್ದಾರೆ ಸಮಥಿಂಗ್. ಕನ್ನಡ ಹೇಳ್ಟಲ್ ಸರ್ ಏನೋ ಆಟ ಆಡ್ತಾ ಇದ್ದಾರೆ. ಇನ್ ಹಿಂದಿ ಸರ್ ಕುಚ್ ಖೇಲ್ ರಹೆ ಹೈ, ಕುಚ್ ಗಲತ್ ಹೈ ಯಹಾ. They will start telling. Because why? Otherwise, why gap? I left the gap to show that if someone comments, sir, factored load you have to consider, means I will tell, I am knowing it. That's why only I left a gap there. Okay. But I don't have to prove to those who are regular. They know how I try to trap. Don't fall to this trap once again. Agreed? Do not take today itself take oath. Patijna. From today onwards, if I calculate anything for working load, before going to limit state equation, I will factor that one. Agreed? Take a vote. In the name of the so and so, I take oath today that in future, when I consider working load and find axial force or shear force or bending on or twisting moment, when I go to design, I am going to factor that one and then design. Okay. Don't make the mistake once again. Start. Okay. Now, calculation of AST. Calculation of AST required. Tell the answer. MU equal to 0.87 Fy into AST into D into 1 minus ASTFY divided by BDFCK. Substitute mu. How much mu? 38.63 10 to the power 6 equal to 0.87 into 500 into AST you are calculating. AST you are calculating. D is 112 into bracket 1 minus AST once again. AST once again into Fy is 500 divided by B is 1000, D is 112, FCK 25. Solve the quadratic equation and take the least value. Tell me what is the AST required. Fast. Solve the equation and tell what is the AST required. Fast. This, if it is an offline class, by this time at least 50% student will give the answer. Why? They got the trick. Answer. Solve this quadratic and tell AST required. If you delay means unnecessary time wasted. Solve the quadratic, give me AST required. Oh, shall I come after half an hour or 1 hour or 1 more week? This much time to give AST required. But don't give wrong value. I will sit here till you give the answer. Not one, at least two person had to give. Because I do not want wrong value. 956.15, somebody's answer. One more person. One person I can't depend. One person I can't depend. MUS 2. Calculator is not on. Abba. $982. Okay, correct. How much? 956.15. Okay. 956.15. According now, the wires are coming in between. Or is it correct answer? 956.15. Correct answer. How much I got? I got for balance section 982. Okay, then correct I think. Okay. No. Confirm past. Another person confirm it. Is 956 correct or wrong? You should not tell wrong answer after some time. I cannot correct it once again. Only one person. At least one more person confirm it. One more person should correct. Okay, done. Over. This is AST required. Now read. Now, as per IS code, minimum steel is 0.12% of BD equal to 0.12 by 100 of 1000 into capital D is 150. That is 180 mm square. Therefore, tell me what is the AST to be provided. AST to be provided. How much answer? Requirement is 956. You should not give less than 180. Tell me, how much AST you have to provide now? You should not give less than required minimum. How much you have to give? How much you have to give now? 956 or 180? How much you have to provide? Requirement is 956. IS code told should not give less than 180. How much you have to provide? 956. Okay. You have to provide 956.15 mm square. Okay. Now, you take 12 torr, 16 torr. If you take 16 torr earlier, spacing equal to, right? I told earlier, area of 1 bar pi by power of 16 square by total area to be given multiplied by 1000. Tell the answer spacing in center to center. Answer in millimeter center to center. what is the spacing of bars? First, if you give 16 torr, what is the spacing? Spacing of bars. If you give 16 torr, you may not give 16 torr later. $210. Okay. Staircase is around 4.2 meter span. Tell me, is 200 is preferred spacing or let it be closer? Tell me. 210 is okay. You can round off 200. Tell me, if the bars are closer, good or bad? For compact bending action, is it better? See, span is 4.2 meter, not a small span. Is it better to have bars little closer or wider? Tell me. No. What is better? Bars at more spacing better or closer better? In general for slab, bars little closer better or wider better? Usually main steel for staircase 200 spacing they will not give. They will closer. Therefore right here it is little higher spacing. So suppose 12 torr. Then you are not wasting steel. Spacing equal to pi by 4 of 12 square divided by 956.15 into 1000. Answer. Suppose 12 torr, then spacing. It is better to give less diameter and closer. Why? Compactness. See, load distribution becomes very uniform then. Answer. Around 100, 125 they will give. Because why? 4.2 meter span is a public building, commercial building. 118.28 center to center. So this is better. Now remember, as per IS code, maximum permissible is 300 or 3D. Leave it. This is very, very high. Don't see that one. So better provide 12 torr. Tell me, round off. 118 came. Round off. 118. Rounding off should be lesser side. 118 round off. 118 round off. 110. Okay. 110 millimeter center to center. Okay. Now, reinforcement is cleared. Now you should check for deflection control. Remember, Excel sheet is there. Directly you can do it. For the batch people, those who are in the ETAB and SAFE batch, to check for deflection, directly Excel sheet is there. But still, for general public, okay, start. Check for deflection. Check for deflection. See, tell me first. L by D actual, danger number. L by D actual. Now remember, since you are going to 12 torr, your D will become more. How much? 150 minus, how much it is? 150 minus 30 minus 12 by 2. Little more D is there. Use it. Tell the answer. Since 12 torr, use it. Revised D. How much D? It is not 112. Little more D is there. Use it. How much? Use it. How much? Little more D is there. Because you are changing to 12 torr, 114. Use it. 114. Okay. Now, L by D actual is 4200 divided by 114. Tell the answer. This is the danger number. This number we want within the limit. If this number is very high, it is going to be unsafe. This is a danger number. Why? More span and thin section. L by D actual. 36.84. 36.84. Okay. Now calculate what is L by D maximum permissible. Permissible. How much? For that, equal to what? Equal to 26 into modification factor on tension side. I told why 26? Because fixity continuity is there. Now, MFT formula. MFT equal to 1 by Varali. 0.22, I am writing because I wrote it there. 0.225 plus 0.0032 into Fs plus 0.625 logarithm to the base 10 of PT. Start one by one. First I require what? Fs. Fs equal to 0.58 Fy into AST required divided by AST provided. AST equal to 0.58 into 500 into required AST is 956.15. Provided AST is 1000 divided by spacing is 114 into pi by 4 of 12 square. I told very clearly, required AST came from formula. Provided AST comes based on spacing. I explained once again today for general public. Those who are in the ETABS batch, I should not tell all these things. Answer. You get Fs in Newton per mm square. You can use Excel sheet. Remember, if you use Excel sheet, by this time, depletion check will be over 10 times. Answer. Answer first. Someone told, guide how to join the batch. After the class, you call me. In first of all, I don't talk about that here. Here in my playlist, you can see demo classes. There are so many demo classes are there. In the demo classes, I have given my telephone number. Not general class, I won't tell. In the playlist, you can see so many demo classes. Demo class for steel, demo class for RCC, demo class for structures, demo class for what? ETABS, demo for finite element method. So many demo classes there. There I have given my telephone number. That number you call after 9 o'clock, after 9:30. Call after 9:30. Not now. How much answer? 279.49. One ನಿಮಿಷ. Okay, correct. Now, tell what is what? Next PT you require. This PT is the required PT. Remember, there is lot of argument throughout India. Some people take PT required, some take PT provided. So many online people, they tell PT provided. Let them come in front of me. I will show them they are wrong. If they dare to come. Okay, now you require what is PT required. PT required equal to 100 into AST required divided by BD equal to 100 into AST required is 956.15 divided by B is 1000, D is 114. Answer. Use the revised value available. Tell me, PT required. 100 AST by BD, PT required. First answer. Sorry. Provided spacing is 100 here. Sorry. 110 provided. And tell the answer. Change this number. Change that number. It is not 114. It is 110. It comes to not 279. How much it comes? Not 279. Spacing is 110. It comes to how much? Sorry, it is not 279. I wrote a print mistake. This is 0.838. This is 0.838. And that number will change. 269.68. So Fs you substitute 269.68, PT you substitute 0.838. Tell me what is modification factor on tension side. Answer. Substitute that value, get me MFT on tension side, on based on tension steel. Get MFT fast. Tell fast MFT. MFT fast. 1 point, it will come 1 point something. Fast. If Excel you are using, by this time, this have been over 100 times. 0.961, na? 0.961. Don't give wrong value. 961. Therefore, your L by D max permissible is how much? 26 into 0.961. Tell the answer. 26 into 0.961. Tell the answer. L by D max permissible 26 into 0.961. It's a good thing happened now. I will tell you why. It's a good thing happened. 26 into 0.961. 24.9899. 25 agreed. 24.99 it comes. Shall I make 25? 24.986 is 99 or 25. Okay. 25. Therefore, see now, what happened? Therefore, conclusion now. How to check for deflection? Conclusion now. See, how you are checking for deflection? Conclusion. Therefore, red color required. L by D actual. L by D actual. This is a danger number. Answer is 36.84 is more than L by D max permissible. Max permissible as per IS code. The number is 25. Tell me, safe or unsafe? Your L by D is, actual L by D is 36.84. Limit is 25. Safe or unsafe? Unsafe. Or remember, L by D actually is how much speed you are going on the road. Higher speed is danger. L by D permissible is what speed is allowed by police department. Maybe in a road, because of hospital, school zone, police put a board. You should not go at a speed more than 25 kilometers per hour. But you are driving at around 37 kilometers per hour. Therefore, they will tell, pay the fine. It is not safe. Good thing happened. Tell why. Good thing. Tell why good thing. Therefore, revision required. Revision required. Tell me why good thing. Tell fast. Why good thing happened? Why good? Fast, tell me. Why it is good? No, tell good. Why? Reason. Why good in the class? It happened. You are learning for practical design. Why it is good? See, unsafe means why I am telling good. You will know once again. Therefore, remember now, lastly, I told after the class is over, I may briefly explain once again for practical. Now I don't have to. Shall I explain now only? Briefly with the calculation. Shall I explain now only so that you can make a note? How fast you can do, what speed you can do, all. Clear? I can explain now only. So time saved. Yes, okay. See, now tell me. So your earlier D was 150 millimeter, which was found to be not safe. So try little more. See, 1 minute. Capital D equal to. See, if the staircase span is 2.5 meter, 3 meter, or 3.25 meter, or up to 3.5 meter, 150 thickness is sufficient. But if it is an office building, it may become slightly unsafe, heavy loading, and span around more than 4 meter. That too for public building, 150 is not sufficient. How much better? Tell me. 150 they will not give. How much they will give? Little more, not 6 inches. For this building, when you see span is 4.2 meter, office building or public building, 200 badabidi. That much wastage is, I told you. See, when you increase the D, double benefit, not single benefit, double benefit. As D increases, L by D reduces. Danger becomes lesser. Second one, as D increases, required AST will come lesser. When required AST is lesser, your MFT will jump. MFT jumps means advantage. Therefore, you will try 200 not required. We will try 175. Sincerely try 175. This time you take 12 tar only. Correct? This time take 12 tar. Why? Last time 12 tar came. This time 12 tar spacing comes little more. Okay, 12 tar only you take. Your actual D equal to D actual equal to 175 minus 30 minus 12 by 2. Keep on giving answer. Remember, I am revising once again so that unknowingly I am explaining full staircase once again. Both ETABS model and practical design. Small d, don't waste time. Give values fast. Give values fast. 139 millimeter. See, I will tell once again. Arrangement is not our problem. Decide center to center span. You take span by 30 you are taken, found to be unsafe, you are taking little more now, that is thickness of 175. Okay, now see then, fast. First calculate loading. Now this is the final chance for you. Remember, consider 1 meter strip. This is very important. So B equal to 1 meter or 1000 millimeter later. Calculate first. Self weight of waste slab. Self weight of waste slab is, thickness of slab is 0.175 into 25. Answer. Self weight of waste slab will come in kilonewton per meter square. Answer. Fast. We are going for full revision so that unknowingly I am explaining once again. Give fast answer. 0.175 into 25. 4.375. Now, this is to be cancelled. Don't cancel. Therefore, equivalent in plan. Equivalent of this in plan equal to 4.375 into root of t square plus r square by t. Tell the answer in kilonewton per meter square. Now this is cancelled. This is a new value which will come. Answer. Root of 250 square plus 150 square, root by 250, meter not required because unitless. See, linear square, root linear by linear. It is a factor. There is no unit for that one. It is a conversion factor. You can take in kilometer also. Ittond palama. Answer 5.1. Okay, 5.1. Now, weight of steps. Remember, formula is whatever is the rise is 150 mm. Divide by 2y, average rise, but not meter, millimeter, meter. 0.15 rise by 2 into 24. That will remain same. 1.8 kn per meter square. Then finishes, we are taking 1.5 kn per meter square. Last remember, live load is 4 kn per meter square. Okay. Now do one thing. Now go to ETAB. Go to ETAB. One sketch for dead load, one more sketch for live load. Span 4.2 meter. Dead load how much? Live load how much? Actually, inclined portion more load, landing portion less load. What you do? See that way. We will take higher load. No time to waste. Sigma m, sigma, that's all not required. Some will tell, sir, this portion load is lesser. So what? Safer side. Consider high load only. So this dead load equal to, this is cancelled, 5.1 plus 1.8 plus 1.5. Answer. 5.1 plus 1.8 plus 1.5. Answer. Fast. Don't waste time. 5.1 plus 1.8 plus 1.5. By the time I finish, it will be fully clear. 8.4 kilonewton per meter square. Live load is 4 kN per meter square. Remember, this is for ETABS. Reaction. 8.4 into 4.2 by 2. Reaction. 8.4 into 4.2 by 2. Reaction. 8.4 into 4.2 by 2. Reaction. 17.64 kilonewton per meter. 17.64 kilonewton per meter. Here, 4 into 4.2 by 2. How much? 4 into 4.2 by 2. Answer. 4 into 4.2 by 2. 4 into 4.2 by 2. 8.4 kilonewton per meter. 8.4 kN per meter. Write a note now. Note. Therefore, in the ETAB model, tell me, supporting beams for that contact length, we will assign dead load UDL of, how much? Tell me. I am not writing now. Those who are the ETAB batch. Tell the answer. When you prepare ETAB model for that supporting beam, for what length the staircase is resting there, for that portion, we will assign dead load of, how much? Bega. Dead load UDL of, how much? For the staircase beams, where contact is there, for the contact length, we will assign dead load UDL of, how much? Dead load UDL of 17.64 kN per meter, and assign live load UDL of, how much? Live load UDL of. Live load UDL of. Live load UDL of for supporting beams 8.4. Write that way. Then tell, this is for ETABS. Now back to what? Now back to RCC. Okay. Now back to slab design. Why waste time? Put a beam of 4.2 meter and write dead load plus live load. How much answer? Tell me. Directly. Insert money. 5.1 plus 1.8 plus 1.5 plus 4. Answer. Once for all, when you design the slab, you don't require dead load separately. Add all the loading. Single step. Answer. Answer. 12.4 kilonewton per meter square. 12.4 kilonewton per meter square. Directly tell maximum BM. Actually, it will give you slightly higher BM because some portion here loading is lesser. Still you are taking more load. Yes or no? Some portion in the end there, load intensity is lesser, but critically load is severe. For same simplification and also for time saving, and one more thing, to be on the safer side, we are taking critical load. Clear now? Yes. Therefore, directly tell me answer. 12.4 into 4.2 square by 8. Actually, 8 also is over safe. Why? Hogging BM will be there. Because of hogging BM, it will reduce. Anyway, safer side. Some will tell hogging is there. Top bar will provide. In the end, I will show you top bar. We will provide top bar. 27.34. 27.34. Now, kilonewton meter. Per meter strip. Per meter strip. Now, remember, you have already taken an oath in the name of, I don't know, say God, that this is for working load. In the life, you should not forget. Therefore, factored maximum BM. Factored maximum BM. That is, I write here, MU equal to, answer. First tell me, MU in kilonewton meter. First. You have taken a oath earlier. In future, this mistake I will not make. MU. If you make the mistake, criminal offense. It is called criminal offense. 41 kilonewton meter. 41. Okay. Now, all this gone. Calculate MU limit. MU limit. 0.36 into XU max by D into 1 minus 0.42 into XU max by D into 1000 into D is 139 square into FCK is 25. This will come in Newton millimeter. Tell the value in kilonewton meter. What is the limiting MR for the single section? Limiting MR. Last time came 40. This time will come more. Limiting MR. This time around 50 will come. See, depth increased by 25 mm. See how severely strength changes. Answer. So many people got bored. They left the class. Maybe they thought they are knowing too much. How much they are knowing, I know it. And again, remember, this is not academic class. Practically, I am telling ETABS purpose or people who are learning design, for them useful. 46.43. Okay. 46.43. Yako doubt. I got doubt. Last time how much it came? Yako, I got doubt about this value. Correct? Huh? I got a doubt. $64.54. See what you are doing. How 46? I told 50 more, it will come more. How it is 46.43? Tell me correctly. 0.36 into XU max by D into 1 minus 0.42 into XU max by D into 1000 into 139 square into 25. So what is this you are doing? How 45? I don't know how 46. I see, because I got common sense. I know last time only 40 came. I was expecting more than 50. See, 64.54. Okay. What to do? This mistake you cannot make. Okay. Therefore, your danger number MU is less than MU limit. Therefore, okay, over. Now, calculate AST required. Directly write formula. The formula you write. MU equal to, how much MU? 41 10 to the power 6 equal to point, formula you write. 0.87 Fy into AST into D is 139 into bracket 1 minus AST into 500 divided by 1000 divided by 139 divided by 25 will solve and tell me what is the AST required. Fast answer. AST required will come in mm square. Answer. First, see, after completing this question, if time is not left, I will upload more classes on this one in YouTube and give information. Maybe that is may not be for public. It may be only for batch. Why? There is some practical examples. I will upload. I won't take classes for this one. AST required. Because next class, in the regular class now, staircase will not come. This is a gift I am giving you. Extra information for learning. Because everybody told required. Almost all replied required. AST required. Again wasting time. See, when people are present, they don't involve. This is what happens. Time is wasted. I am not calculating. I am doing rough calculation. Huh? What is one? Was something wrong? $840, around 800. 761.52. 761.52 mm square. Okay. Now, which is less than, this is more than minimum requirement of 0.12 by 100 of 1000 into 175. Tell what is the number here? Minimum steel. You should not give less than that number. How much that number? 0.12 by 100 of 1000 into 175. What is the number? What is that number? That number 210. Okay, anyway, 210. Therefore, this is still valid. Till next, calculate spacing. Spacing of 12 torr is pi by 4 of 12 square divided by 761.52 into 1000. Calculate spacing. Last time spacing came 100 and something. Now see, because you have given more thickness, steel will come lesser. Now spacing may come around 150 mm. So economical. Spacing. Now you require lesser steel. Because you have given more thickness of concrete. Your thickness increased, steel will come lesser. Answer. Spacing. See, not giving answer. Spacing. 147.93. 147.93. Okay, we will provide how much? Provide 12 torr at, see, 147.93 means practically, tell me how much he will give. He won't give 140. Safer side. Tell how much he will give. People want safety. How much he will give? He won't go for 140. He will round up to 5 inches. How much? Safer side. How much he will give? He will tell, okay, what is this cost? Safer side for staircase, 125. We also liberal. Say at 125, center to center. Safer side, millimeter, center to center. Okay, now check for deflection control. Check for deflection control. Okay, start. First calculate danger number. L by D actual. This is the danger number. Danger number equal to 4200 by 139. Now tell the answer. L by D actual 4200 by 139. 4200 by 139. $30.21. Okay. 30.21 is a danger number. Now, we want L by D max permissible equal to what? 26 into modification factor on tension. To get this one, write the formula for MFT. You write 1 by something right there. Then start. First I require what? Fs. Fs equal to 0.58 into 500 ASY into required AST 761.52 divided by actual provided AST based on the spacing is 1000 by 125 into pi by 4 of 12 square. Everything thoroughly explained. Answer. This will be a plus. And PT required equal to 100 into AST required by BD equal to 100 into required steel is 761.52 by 1000 divided by 139. Give this will come in Newton per mm square. That will come in unitless. Answer. I want both the answer. Then substituting, I want modification factor. Okay. Tell the answer. On tension side. Substituting, I want MFT on tension side. Do all these three. Formula 1 by 0.225 plus 0.003, 1 by 0.225 plus 0.032 Fs plus 0.625 logarithm to the base 10 of PT required. All three values required. Answer. Fast. I want all three values. Fast. First tell me Fs value. If Excel sheet is there, these are all not required. See, actually for our batch, I don't have to tell. Excel sheet is there. Still complete here. Answer. Taking lot of time. Tell me one by one. First Fs value 244.51. Tell me PT required 0.547. Okay. With that data, what is MFT? With that data, what is MFT? Over question. Nothing is there now. Now just one rough sketch I have to give. I will give that rough sketch. One rough sketch I will give you. Detailed sketch will come in the project later. Some IS code provisions are there. That all I will not tell today. Today I will tell you rough arrangement of steel. MFT. What you are doing? See, this is the problem of live class. No, only limited number of people are participating. Others will not give any answer. MFT. Okay, I will take rest. If you don't give, what I can do? With that value, MFT. You are actually wasting time. 1 by 0.225 plus 1.185. Correct. I can make out. 1.185. Okay. See, anywhere, in case there is a calculation mistake, you don't consider it. Now, therefore, L by D max permissible equal to 26 into 1.185. Tell the answer. 26 into 1.185. Answer. 26 into 1.185. 26 into 1.185. If anything is wrong, you correct it. Our important is understanding here. Calculation mistake, I am not responsible. 30.81. Oh, yo, narrowly escaped. 30.81. See now. Therefore, see here, your L by D actual danger number, which is 30.21, is less than L by D max permissible of 30.81. Safe or unsafe? Tell me. Safe or unsafe? See, just 150 increased to 175 suddenly becomes what? Safe or unsafe? Safe or unsafe? Speed is 30.21. Police is permitting up to 30.81. Safe. Now, by chance, if it becomes unsafe, you don't have to once again increase the thickness. What you can tell me? Instead of providing 12 tar at 125, reduce the spacing. Provide 12 tar at 100 spacing. Suddenly, your FPS will drop down and therefore it will come safe. This I told you by providing little more steel. But that you should do only when you get marginal unsafe. Last time serious unsafe. So we increase thickness. This time marginal, so you can do it. Remember it? I told earlier. Remember or not? Marginal unsafe, you can do it. Slightly increase the steel. Remember it? Okay. Now, last step. Everything is over. Main steel is over. Lastly, calculate what is the distribution steel. Distribution steel. Distribution steel. See, area of distribution steel, area equal to minimum reinforcement. How much? You told already minimum steel equal to, how much you told? 210 mm square, correct? 0.12%. 210 mm square. Take only 8 tar. Tell the spacing. Spacing. Pi by 4 of 8 square divided by 210 into 1000. Tell the spacing of distribution. Pi by 4 of 8 square by 210 into 1000. Distribution spacing. Over. Now just one sketch required. Pi by 4 of 8 square by 210 into 1000. How much? Distribution spacing. 239. 239 millimeter. Center to center. IS code tells not more than 450 to 5D. Ayyo, too high. So provide 8 tar liberally at 200 center to center. Clear? Provide 8 tar at 200 center to center. Agreed? 8 tar 200. Little liberal. Okay, no problem. Provide 8 tar 200. Okay, now over. Lastly, put a sketch, rough sketch. See, some more IS code provision for staircase detailing I will discuss in the ETABS class. Remember, not here. In the ETABS class, I will tell you more discussion. Because why? When you do the project, detailing will come there. There I will cover. And there I will tell some more thing for you. But open well staircase type, one flight goes this way, one flight goes this way, one goes this way. Principle is same. How to transfer the load there 2 mid-landing beams are required. Clear? In the open well staircase, you require 2 mid-landing beams. Clear or not? Not 1 mid-landing. Correct? You require 2 mid-landing beams. Usually it goes round the lift. Lift will be there, round open well. Yes or no? There will be 2 mid-landing beams. One at first flight, one second flight level, then floor. That all I will tell in the software class, load transfer. Now, rough sketch, see, just one flight, put the sketch. Cross section to first flight. See, start here. This is the slab coming here from this side. With this side, see, rough sketch. Rise, 1, tread. Rise, tread. Rise, tread. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11th rise, no tread. It will go this way. Okay, now here. If I join, all these should come in one line. Okay, agreed. Thickness of waist slab is 175. It will come this way. Leave it here. Here there will be a floor beam. Then here, out of scale. Ayyo, little out of scale. Okay, okay. Here also there will be a beam. Beam you are not bothered. Beam you are not bothered here. Okay, now rise here. Remember, the rise equal to 150. Anywhere remember, tread equal to 250. Dimensions, see, this is 200. From here up to here is 2000. 2500. From here to here, clear distance is, landing is 1500. This is 200. Thickness is, waist slab thickness is what? Waist slab is 175 thick. No space to write here. 175 thick. Now see, correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ah, yes, correct. Now see, predominantly sagging. This is the bottom steel, main bar. It will come here. This is your main bar, 12 torr at how much you have given? 125 center to center. See, this is the distribution steel. That is 8 torr at 200 center to center. Now, what will be done is, these bars, you require bottom here. No. What they will do is, all these bars will be taken to top and turned here. Clear now? All these bars will be directly taken. I think you know it in practically. Yes or no? These bars will be directly taken to top. Yes or no? Tell me first. Correct or not? These bars, they will take the top and turn it to take care of any hogging beam there. Tell yes or no? Yes. Now, there is shortage here. So here, separate bottom bar will be given. Same steel. Whatever this steel, same steel. 12 torr at how much? 125. That bar will come up to here and they will turn it. Then, further, also, usually here they provide some extra steel. Have you seen that one? Some extra steel they will provide here. Everybody gives here. Have you seen that one? Tell me. Have you seen that one? Extra steel there. Have you seen it? Their top, that junction, they provide extra steel. Have you seen or not? Yes. Now, here, here, slab will continue. I don't know what is a slab. These bars will come and what? Be turned to the slab. And here, again top bar will be given. Those bar, some people take this way and take this way, or what ideal is, better take this way. Extra bar for hogging beam. And here also, wherever steel is there, you have to provide distribution steel. See, here also, you have to give distribution steel. Here also, some distribution required. Rough profile of the staircase. What is the distance you have to extend this bar, up to where you have to extend, all given in SP34. During the project, I will explain all those details for you. Clear now? Not now, because now this is design of staircase main principle. Load transfer, then conversion of the weight, and then how to decide slab thickness, how you calculate bending moment, then how to point steel, etc. Approximately means detail only I told. Okay. Further, I will tell in the software class. In the software class, during project, I will see once the project is completely over. Lastly, when everything is over, I will continue the class for 2 more classes. When after the project is over, means what? Building model done, earthquake, etc., everything considered. See, not only dead load, live load, including earth load. And once your result comes, then I will tell you how to detail that one. Beam I will not tell. Tell why. At that time, beam I will not tell. Tell why. Reason. Beam I will not tell. Why? Reason. Beam I am not telling. Tell the reason. Beam I will not tell. Reason. You don't know the reason. Already since part 3 classes, we are struggling for a beam, that 8-span beam. Yes or no? How much I explained there for you? Top steel, bottom steel, etc. So beam I will not tell. Slab also I will not tell, because when I go to safe, as soon as I make safe model, simultaneously I will explain how to give slab reinforcement, so that in the project, see the column I will explain, and staircase I will explain, and footing part I will explain. Clear? After that only, drawing I am not giving here. Detailing. How you have to give detailing for draftman. He will prepare drawing and send it back to you. You check it and verify. Now, staircase portion. See, marathon from 5 o'clock, nearly 4 hours. And now, further half an hour is there. I won't continue. Extra information I will upload in the YouTube, or if YouTube, it is possible that if I want extra information not to be made public, what I will do? I will make unlisted and upload to you. Agreed? For the group people, I will take the YouTube only. Why? Recording becomes easy in the YouTube for me. I can record in the camera. Full board can come. I will take extra information. I will record in the class and explain so many things. And then I will explain in the YouTube, but unlisted, link I will send you. General I will not give. Because why? There are so many confidential parties there. Confidential means what? Sometimes rounding off safer side. Public I don't want to tell it. Those who are my usual batch people, for them I will tell. Okay. Hope staircase class, you told all required. Really useful? At least some information you got for staircase now. By attending the class, some good information you got. At least your confidence level now is better. By this class, your confidence level is better now. Or suppose this class is, suppose you decided not required, then tell me, you would have really missed something. If majority people tell, sir, not required, sir, we want to go to safe, time is not there. If by chance I have not told these things, you would have missed something then important or not. Something important about load transfer all, you would have missed then. That's why I told, to the best of my possibility, in the available time, I will take a class for staircase. Coming week, Saturday, I am completing that beam. See, top bar up to where extend, bottom bar, what? Where to curtail. That will take nearly 1.5 hours. There are some important points there. What? That number problem. Complete beam I will finish on that day. Coming Sunday, tell me, you are starting. Coming Sunday, we are starting. What you are starting? Coming Sunday, what you will be starting? Finally, you are starting. Coming Sunday. So be ready on Sunday. We are starting safe. Okay. Thank you. Now 9 o'clock over. I stop because today too much of shouting also is there. Usually YouTube class means shouting is more. Because by public, some people, they don't know something. So I thought when I explain, little more explanation. Okay, thank you. We will meet on Saturday. I will complete the beam detailing. Sunday, we are starting safe. Okay, thank you.